give me roses. I wish she could again, but that was on the outside, and things were different then. We feel our world together.
Good evening and welcome to our lockdown live stream prisoner edition. Hope you enjoyed our introduction there. Before we commence, I'd like to say that in the spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to the land, sea and community. We pay our respect to the elders past, present and extend that respect to all Aboriginal and Torres Strait Islander people today. Tonight, the Astronomical Society of Victoria is proud to bring you our lockdown live stream prisoner edition as Melbourne enters its 5th lockdown. Not fun for anybody. While we'd hope to share the night sky live with you in person at Caulfield Racecourse, the lockdown scuttled that idea, and our backup live stream has been derailed somewhat with a whole lot of cloud and rain over Victoria tonight. However, don't fear, we have a third plan. We aim to share with you a tour of the Milky Way using a program called Space Engine, and images that our astrophotographers have taken throughout their own journey of astrophotography. So grab a drink, get cozy, sit back and enjoy the ride as we fly our way through the Milky Way and beyond. I'll now bring into the stream Ronnie Biggs. Not going to rob any trains tonight, I hope.
No, I'm out in Brazil. I'm on the run, so just don't tell anyone.
I won't tell anybody you're there. We have Steve McQueen. He's looking a bit old now.
Yeah,
Cool motorbikes, I hope.
Yeah, I can see sort of. Yeah, the motorbike took my hair off. So
we have number 6.
Good evening, everyone.
And we've got Piper from Orange is the New Black.
Hi all.
And we have M87, which is our black hole, who is Orange is the New Black Hole. So tonight, the guys are going to share with you their images that they have taken, and we're going to talk about those images. It's from the list of objects that we would have looked at Caulfield Racecourse and that we would have live stacked for you tonight if the clouds weren't there. So we'll get Space Engine up on the screen, and we're going to start from Melbourne. And the first object that we were going to look at was going to be the moon. So we're going to move from Melbourne to the moon and have a look at the moon, and then have a look at some photos of the moon and have a bit of a chat about the moon. If you have any questions, pop them in the chat, and we will get to those questions, pop them up on the screen, and answer them to the best of our abilities. So we're moving around here now from Earth, facing towards the moon and about to zoom in on the moon and have a good close look at it. Now, Steve, have you got some information, some facts about the moon?
Yeah, this is really good actually, because if we were at Caulfield Racecourse and looking at the moon live, it would look pretty much like that. So it would be in the northwest, high up above, looking from Caulfield, looking up above the city, and it's 7 days old. So it's at what we call first quarter. So we go from new moon, when the moon is sort of dark, if you like, to first quarter, when it's half full, to full moon when it's full, and then third quarter when it's half full, and then back to new moon. So, and it does that over a period of about a month, 27, 28 days, something like that. So, as I say, it's first quarter. If we were looking at it live and we had a clear sky, it would be fairly close to the first magnitude star Spica, which is in Virgo. So at the moment, just a couple of stats. The moon at the moment is, I've got the exact figure here, 367,918 kilometers away from us. And it's at magnitude minus 9.8. So when it's a full moon, it goes up to about magnitude 14, I think, something like that. But because it's only sort of half full, if you like, magnitude minus 9.8. So it's by far the brightest object in the sky at this moment in time. Along the line that runs between the sort of the dark side of the moon and the light side is called the terminator, and you can see some of the nice craters along the south side there. Those three fairly prominent ones in a line are Ptolemaeus, Alphonsus, and Azakel. I can pronounce them correctly. Oh, that's great. Zooming in on them. They're quite interesting ones because they sort of demonstrate a little bit of some of the sort of the ages and the phases of how the moon has developed. So the oldest one is the top one there, which is Ptolemaeus. And you can see it's got a very sort of smooth surface inside the crater. And that's because it formed very early on in the moon's life. So probably something like 3.5 billion years ago. And the moon at that time was fairly molten. And it's filled up with lava early on in its life. As you move down to the bottom one, that's the youngest of the three, which is Azakel. And you can actually see that that's much rougher inside. You can actually see some mountains in the middle there as well. So that didn't fill up to the same level with lava. And you can see the sort of rougher edges of the crater. Great views there, really. If we can zoom back out a little bit and just go back up to the towards the top half, we'll see another nice feature on the moon. And there's so much to look at on the moon, which you can see through a small telescope. We have in the ASV a thing called the Lunar 100 Challenge, which is 100 really great things to look at on the moon, and it was put together by one of our members, a friend of mine called Ron Boren. So that line of sort of crinkly bits, they're the Apennine Mountains. So they're quite high mountains, and there's some good features further in there as well. So just a very quick sort of snapshot of some of the things that you could look at on the moon. I don't know if if anyone has got some good pictures that they've taken themselves.
I've got some pictures, but they're not good.
They're not good. Let's go to Steve McQueen's image. While we're looking at this, do you have a question, Steve? Mm-hmm. Number 6, sorry, I should say number 6. I'll treat you as number 6. Nicholas wants to know, sometimes the moon looks like you're looking into an LED light. Why is it so bright?
So it's reflecting the light from the sun. So the fuller it is, the brighter it is, in effect. It's interesting, really, because the moon is actually quite a dark object. And so its reflectivity isn't actually that great. The surface of the moon is actually most of it is a fairly dark colour. And it still reflects so much light. The interesting thing is that when the moon is a new moon, So when there's no sunlight being reflected off the moon, you can actually still see the moon. And that is because it reflects the light bouncing from the sun onto the Earth, and then from the Earth over to the moon, and then back into our eyes. And that reflected light is called Earthshine. So it's particularly good 1 or 2 days after new moon, when the moon is a very thin crescent, but you can still see the rest of the moon lit up with what we call Earthshine. Does that answer the question? I suspect it does.
I think it does beautifully. Now Steve. Well, sorry, Mr. McQueen.
Yes.
This image here. What did you use to take this photo?
Very simply, I used a Nikon DSLR on the back of my refractor, and what was it? The exposure was 1/60th of a second. That's all I used because this was so bright, and so I imaged that, and this is just a single shot. So I've just put it into Photoshop, played around with some of the levels, and to get what I got. But I'm pretty happy with the way this one turned out.
This image here. This is from the lunar eclipse. Am I right?
Yep. Just before it was just about total.
Now, what did you use to take this photo?
I didn't look at those.
What equipment do you normally take?
Well, that was taken with the ED80, I believe. Yeah, I think so. I really can't remember the moon shots. Sorry, have you still got that up there?
We do, yes.
I'm having a bit of an issue here.
That's okay. What we might do is jump over to Mr. Ooh. There we go. We've got you back again. Now, what we might do, black hole man, orange is a new black hole.
Yes.
If we can move now to Jupiter, we'll go to Jupiter. We'll go in order. So we'll move from the moon to Jupiter. So if anyone's got any questions about Jupiter that they'd like to ask, let us know, and we can try and answer them for you. So now we're going to pan around to face Jupiter. You can see the little arrow on the bottom of the screen there. As we turn around and zoom into Jupiter. A little bit bright. It's what it looks like through my 8-inch Dobsonian. Oh, there we go. Now, Steve, what do we know about Jupiter?
Well, again, this is really good because I'm thinking the date and time are as we would be seeing Jupiter, which is really good. Jupiter is, of the objects that we're going to look at tonight, Jupiter is sort of the next nearest object that we'll be looking at tonight after the moon. If we were at Coalfield Racecourse, Jupiter would actually be very, very low in the east. In fact, it would, what's the time now? It's 8:15. It would only just have risen above the horizon over in the east. Currently, Jupiter is 624.7 million kilometers away. And it's pretty bright, minus 2.8 magnitude. You could just see the red spot kind of over on one side of Jupiter. And during the course of the evening, that spot would actually move across the face and disappear off the other side. And it would disappear at about 1:30 a.m. on Sunday morning. Now, this is also very interesting because that black spot is, and you can see a bright light moving across there.
Can you pause that? Can you pause that, Lee?
Yep.
There we
That's
go.
that's the shadow of the Galilean moon Io as Io transits across the face of Jupiter. So tonight we actually would have had quite an unusual opportunity to view that transit, and you can actually see the you don't need these sort of computer simulations. We would have been able to see with a clear night. We would have been able to see that shadow moving across the face of Jupiter, which for us astronomers is quite an exciting kind of an event.
Now, Steve, I'm having to jump between two screens because for those who aren't aware, who are watching this on the ASV Facebook and ASV YouTube, this is also being pushed across to the Herald Sun's Facebook page, and our chat doesn't see their question. So there is a question. Brody is asking, how large is Jupiter compared to Earth?
It's, well, to put it in context, Jupiter, the mass of Jupiter is significantly more than all the other planets combined. So Jupiter is by far the largest planet. I mean, Saturn is the next biggest, and that's a really big planet as well. But Jupiter would be able to contain the mass of all the other planets. I think it's something, I'm guessing a little bit here, but I think in terms of diameter, I think Jupiter is something like 30 times the diameter of the Earth. Certainly the red spot, which is a huge storm on Jupiter, is actually significantly larger than the diameter of the Earth. It's a massive object.
We also have a question from Kevin, wants to know why the Galilean moons rather than just the moons.
Well, that's a really good segue because I was going to talk a little bit more about the Galilean moons. So thank you for that question. So Jupiter has a lot of moons. So there are currently, if I look down at my notes, 79 moons, of which 53 have been confirmed, and 26 are still to be named and confirmed as well. Galileo Galilei, when he was looking at, he actually was the guy that discovered the 4 Galilean moons. So he could only see the 4 largest moons of Jupiter. Now those moons are big enough that you can actually see them actually through a pair of binoculars, but particularly well through a small telescope. And Galileo used he looked at what was happening with those moons over a period of time, and he could observe that they were moving around. They weren't sort of static, and they changed positions as well. And with his phenomenal intellect, he was able to ascertain that the reason that they were moving around was because they were actually revolving around Jupiter, the planet. They weren't just sort of little stars in space. So he was actually challenging, the flat earthers and all of the religious hierarchy at the time by daring to suggest that these kind of things were happening out in space rather than, the Earth just being at the center of the universe. So the 4 Galilean moons, the nearest one to Jupiter is Io. The next nearest one is Europa, then Ganymede, and then Callisto. But as you observe them from Earth, they seem to change position because obviously as one of them moves round the back of Jupiter, as we look at it from the front, it appears to get closer, and then some of the other moons will move further away. So sometimes Io isn't the closest moon as we see it from Earth to the planet. The other moons can kind of sneak in between. And sometimes you can't see all 4 of the Galilean moons because they're hiding behind the back of Jupiter. They get shy every so often.
Now, we've got another question here. Do the moons of Jupiter present like our moon, waxing and waning?
I can answer that one as well. No, they will always appear as just a sort of a roundish object. The waxing and the waning. So when we see the crescent, that's really for those objects that we see between us and the sun. So when they're off to the, think of like Venus and Mercury as well, and also the moon. When they're sitting off to the side of us, the sunlight is sort of reflected off the side of the object, and we see the light from the sun in a sort of a crescent shape. As you go sort of the other side, so where the planets and the moons are further away from us than the sun, then they only really ever appear fully illuminated. Although occasionally, I think Mars can, as it moves off to the side of us, that can also get a little bit of a crescent shape. It's quite mesmerising, this program, isn't it?
Yeah, I'm having fun flying around.
Yeah, just looking down at my notes, Jupiter is 2.5 times more massive than all the other planets combined. A couple of other interesting facts. Jupiter spins very, very fast. Do you remember I was saying about the red spot will move across the face of Jupiter and disappear over the other side during the course of an evening? That's because one Jupiter day, so it going all of the way around, is only 9.9 hours. And it spins so fast that it's not completely round, it's a sort of spheroid. So the poles are actually flattened in, and around the equator bulges out because of is that centrifugal or centripetal force?
Centripetal.
Centripetal, thank you.
That one. Now, we've got...
one that trips you up, that's how you remember.
One that trips you up. That's a good way of thinking about it. So this is an image that was taken of Jupiter by Gerald, one of our astrophotographers, who's on the stream tonight, is Steve McQueen. Gerald, what did you use to take these images?
What I did was used a dedicated astronomy camera, which is in video mode. And so what I did was I took about 1,000 frames and stacked those frames together to achieve this. But as I was watching the planet, it was bouncing all over the place due to the atmospheric conditions. It was a pretty unstable night. So that's why this image isn't probably the best you're going to see. But you know, I was happy with the fact that I could see some of the clouds on Jupiter, and yeah, I think there's a red spot there too. I'm not sure, but yeah, that's how I could achieve this.
To the right there, I think.
Yeah, it could be, or could be even be a moon in there somewhere too. Yeah.
So while we're looking at this one, Steve, we have another question. Whoops, no, here we go. Question from Sally, who wants to know, what are the 2 different colours on Jupiter? I'm assuming she's talking about the bands, the differentiation in the colours in the bands.
I think you've answered it there. It's the cloud bands.
Or we've had that answered by our social media team. The colours of Jupiter's atmosphere are created when different chemicals reflect the sun's light. Most of Jupiter is hydrogen and helium, but the top of its clouds are composed of ammonia. Ammonia crystals with trace amounts of water, ice droplets, and possibly ammonium hydrosulfide.
Wow. When we're looking at Jupiter through a telescope, so through an eyepiece, what I do is I I sort of gauge what we call the quality of the seeing on the night by how many of those bands those cloud bands I can actually see in the object. It's when you look at it through a telescope, it's quite a lot smaller than this, but I can nearly always see those two very obvious cloud bands either side of the equator. But when the seeing is very good, I can see probably 4 or 5 bands, which is great.
So I think we might jump over to Ronnie Biggs' image. This was from 2 weeks ago. Tell us, what did you use to image this one?
How you going? I used a little same thing, a little dedicated planetary cam. I can just get this up here in the tick. Where are we? That's what I used. It's a little ASI. It's a 120 MC, so it's just a little planetary cam. And through my Newtonian, and you can just see the red spot just about here. You've got Io and Europa here, and that red, that's a, well, that's on my screen.
Not even a star. Now that camera that you showed us, how much is that?
$230.
$230. And what your rig, your entire setup, how much did that cost you?
Here it is here. My telescope cost me the same thing, $200. Camera, I think it was $240. The mount itself, so that's the most expensive part. That was $700, but this whole lot's roughly $1,000. You know, a bit over, just a fraction over. There's my other little camera. So that's the camera which I was using. And that's just a quick. The seeing was bad, and also my collimation was really bad. I had a bit of a smash scope, and then I've sort of put together, taken outside, and I didn't do any collimation until I checked it, and I used a laser, and the laser was pointing right at the corner of the mirror. So if you know how it should be pointing towards the center of the rear mirror, it was way out. So that's why I can see fringing on this side here. It's just a color fringing, but I sort of, that was done in a free program called Auto Stack It, and then a bit of work with Registacks to do, you know, I'm still sort of learning these programs, but a lot of these programs are free. So you can do simple stuff, or you can go as big as you want. You can, you know, those cameras can be $3,000-$4,000. But this is it's a small little camera. It takes reasonable images, you know, just a quick, simple. Yeah, I'm quite happy with it. But that's a good image of Jupiter, I think. That was about a minute because it's been so quick, you can't really do any more. So I took a video for a minute, pulled about 2,000 frames, I think, but I dumped 1,600 of them. I think even more. So I kept 15% because it was moving around a lot. It was very bad seeing that night.
Wonderful. Now, that you did that with your equipment. We've seen what Gerald's done with his. I'm going to quickly share a screen and show everyone what can be done with a phone camera and I think it's a $600 or $700 Dobsonian telescope. And this is my image of Jupiter using a Huawei P30 light. It's a single-click image. So it can be a very cost-effective thing to get involved in. You don't have to spend a lot of money to get stuck into astrophotography. As I said, you know, this is just with a phone camera attached to the telescope eyepiece and it's just a single photo of Jupiter.
No Barlow?
No Barlow. No, none at all. So I just zoomed in, used a 6x zoom on the phone, focused it, manual focused, and took an image. Just adjusted the lighting and took an image. And you can see the bands of Jupiter even in this image.
So that's about as good an image as you would probably ever get just looking through an eyepiece. So I can actually see 4 bands there. The two big dark ones, and then one below and one above. I can actually see there. That's about as good as you will get through just by looking with your own eye, as it were. That's good.
So I think now we're going to jump across to the next object. And that next object will be, we're going to move from Jupiter, we're going to go across to Saturn.
Yes. Hang on a second.
What's this program you're using?
This is called Space Engine. So it's almost like a 3D.
Is this a free program, or do you have to pay for it?
No, it's not free. Lee will be able to let us know what the cost of Space Engine is.
There's a couple of different versions of it. There's a standard version. They're available on Steam. Quite a lot of people would probably know what Steam is. It's a sort of a digital content delivery software platform. A lot of things like Kerbal Space Program and things like that are on there. It's I think it's $39 for the standard program and $89 for the Pro version. So the Pro version actually allows you to. There's quite a lot of other features and sort of downloadable content with it, as well as allowing you to create video content. So you might see a lot of people who do video streaming on YouTube and so on, where they're doing astrophysics sort of presentations. They might show black holes or stars or planets and so on, and there's a good chance that it's been created with a program like this.
Now, that price, someone's asking, is that per month or is that a one-off fee?
That's just a one-off.
One-off. And there is, I've noticed in the chat there is a free version that you can download, a trial version or a free
Correct.
version that you can download as well.
Correct.
This one just has a lot more features in it, I'm assuming. Now, we are looking at Saturn, everybody's favourite.
Yeah. So it took a little bit longer to get to Saturn, and that's because it's more than twice the distance to Saturn as from Earth to Jupiter. So do you remember Jupiter was about just over 600 million kilometers? Saturn at the moment is 1,342.4 million kilometers. Not as bright as Jupiter. It's a lot further away, and it's not as big. So magnitude 0.3. It's the 6th planet from the Sun. And it's the most distant planet that is visible to the naked eye. And it goes around the Sun every 29 years. It takes 29 years. So the Earth takes obviously 1 year to go around. Jupiter goes around every 12 years. And Saturn takes 29 years to go around the Sun. The naked eye visible, so we don't really have anyone that discovered it, but the person that discovered the rings of Saturn was actually also the same person that discovered the moons of Jupiter. So it was another Galileo discovery back in 1610, all that time ago, with his little telescope that, had the objective lens on it was about an inch or so in diameter. And it was like looking through at the objects through a drinking straw. Now you can probably see actually there that that because Saturn also revolves, spins really fast, and that flattens the two poles and makes it bulge out, perhaps even more so than Jupiter. So one Saturn day is 10.7 hours. It's actually the least dense planet in the solar system. It's less dense than Jupiter, and it would float in water. It's a gas giant. Yes, it's, as you get towards the center, it's going to get fairly dense, but it's still a gas giant. So it would actually float in water if we had it here on Earth. Be a bit difficult. At the equator, I think this is in part due to the fact it's spinning so fast. It's a really, really windy place, and there are winds up to 1,800 kilometers per hour at the equator. That's pretty windy. Saturn is the planet that has the most moons, 82 moons currently, and that number's going to go up as we send more spacecraft out to these planets, and we see more and more stuff revolving around. So currently 82 moons, 53 of them confirmed. That's actually the same number as Jupiter, believe it or not. 29 not named as yet. Here's an interesting little fact. About 2 tons of Saturn's mass actually came from Earth. And what that is it's not the sort of a chunk has flown off from Earth and zoomed off and hit Saturn. It's actually the Cassini spacecraft, which weighed about 2 tons, and that was deliberately crashed into Saturn back in 2017 after it had finished doing all the fantastic work, taking pictures for quite a few years of these wonderful ring systems.
We're pretty good at sending our rubbish everywhere, aren't we?
We are. There's actually four spacecraft have visited Saturn. Pioneer 11, the 2 Voyager spacecraft, 1 and 2, and then the Cassini Huygens mission. So 4 of them. There's actually been 8 spacecraft that have visited Jupiter. It's actually the 4 that visited Saturn actually visited Jupiter first, and I expect that may have been because they were using Jupiter as a big gravitational slingshot to fling the spacecraft on out to Saturn. Yeah, so 8 spacecraft have visited Jupiter, including the New Horizons one, which is the one that went out to Pluto. So almost certainly that was slingshotted from Jupiter. They use the phenomenal gravity of Jupiter, sort of as the name suggests, slingshot the spacecraft on.
Now, this is one of Gerald's images. So, Gerald, this is with the same equipment you used to take the image of Jupiter, I guess?
Exactly. Yep. The same kind of procedure with the using video. But this time, I think the conditions are much better. So I could actually see the Cassini division, which is the black ring you see in there. Yeah, no, I was quite happy with this one.
And then we've also got one that's taken by Andy. So, Andy, this is obviously the same equipment you use for Jupiter as well.
Yep, it's the little ASI camera. I'll just try and zoom in. You can see the Cassini division, but you can also see the next division. It's called, it starts with an E. I'm not very good at pronouncing it.
Enki division?
Yes, that's it.
What was that called?
Enki.
Enki.
Yeah. But I just only on one side. It was the same sort of thing. Still taken with this gear, except the only difference is I pulled this camera off my guide scope and put it in here and I didn't have my camera, and that's my little imaging tent. I have I image out there normally. I'd be out there tonight, but it's raining. But yeah,
it's raining in a lot of places.
Yeah. So back to Saturn, and Saturn's it's amazing looking at Saturn. It just with the eyes, it's something you just once you see it, you're hooked to astro. It doesn't matter, even it's with binoculars. If you can even put binoculars on a car or use a tripod or something, you can see Saturn's rings quite. It just looks different from any other planet, and you're hooked for life.
I agree. It was the first object I saw through a telescope as well. Now we've got Anne-Marie's got an image that she took of Saturn.
It's not a very good one. It's my very first.
When did you take this?
It was just a couple of weeks ago. It's the very first time I've ever tried having a go at Saturn. So that was just taken with my reflector telescope and slightly bigger than the camera that was shown before. This is a ZWO ASI 174, but also just a little video. And it was just one video, and I put it together, and that's it. That's as good as it gets.
Well, that's still better than the phone ones, but still, once again, that's with the phone. This is obviously with the phone attached to the telescope, the Dobsonian telescope again. So it's just an 8-inch telescope, 24mm eyepiece, and then the phone zoomed 6 times. And same as I did last time as well, where it's just focused it manually, adjust the lighting, and took a single click. So that, Steve, I know you're going to say that that's pretty much what Saturn looks like when you visually see it through an 8-inch. And probably what we would have seen tonight at Caulfield.
If the seeing is really, really good, you can just spy the Cassini division in my 10-inch scope, but the seeing has to be really good. When we look at Saturn through the big 40-inch telescope that we have at our dark site, then you can definitely see the Cassini division.
There we go. There's a nice view of the Cassini division.
Yeah, I thought I'd go from the top down because I wondered if you wanted to mention the hexagon, Steve.
Do you want to talk about it?
Not necessarily.
He's just handballed that one straight to you, Steve.
Sorry. Well, you could, yeah.
Look, what I know, it was discovered by the Voyager mission in 1981, and as you were saying, with the Cassini-Huygens craft, which came in later in 2006, and it's actually changed. It used to be a mostly blue color, but it's now sort of more of a golden color. It's one of these things that it's, I suppose, with so many things, unknown really. There's many hypotheses around it, just like the storm on Jupiter. It's just amazing to consider that you've got something that's effectively so round or circular or obloid, spheroid, however you want to term it, but then you have something that's quite clearly, it is hexagon in shape. It's 6-sided. It just sort of boggles the mind to consider that there's something so. I mean, it's you can see obviously there's curves, but we say in nature there's no straight lines, but it's about as close as you could get on this sort of astronomical level, I think.
I've just done a quick search on I've just asked that well-known astronomer Dr. Albert Google, and just to read back so it's actually, because I wasn't sure whether the hexagon was anything to do with like an aurora like you get on particularly on Jupiter, but it's not. It's the clouds at the top of the planet, and I'll just read this bit. Smaller storms interact with the larger system, and as a result, effectively pinch the eastern jet and confine it to the top of the planet. The pinching process warps the stream into a hexagon. That's fascinating, isn't it?
Now, before we move, we have one last question. So before we go to, I think our next object is Alpha Centauri. But before we go over to Alpha Centauri, we do have one last question. And it'll be a very good explanation about the Cassini division. And if you can leave that position on there for the moment, Lee, where we are at the moment, if you can hear me, don't move yet. So the question is, do any of Saturn's moons orbit between the rings?
None of the bigger moons. I think there are some very small objects that, because the rings are made up of dust and small rocks and just stuff, if you like, and they're actually really thin. So the Cassini division is a sort of a gap, if you like, between those dust rings. That's why it appears black. So no, there aren't any moons that orbit between the rings. Oh, here we go. Oh, we've had support from afar here.
I thought there was some.
Two other known regular satellites orbit within gaps in Saturn's rings.
Who set you straight, Steve? Who was it?
That's Linda.
Yeah, well, the moons are dust clearers, and eventually Saturn will
what I thought, yeah.
not have rings. In I don't know how many million years, but the rings will disappear, and the moons will slowly clean up, collect all the dust.
We're chasing a moon through the ring now. All right, now Lee, if you'd like to fly us over to Alpha Centauri. And everyone strap in and enjoy the ride. This one's you might see some stars move past us on this one. Nothing's moving. Why is that, Steve? Why are there no stars going past us on the way to Alpha Centauri?
Well,
It's a long way away.
Yes, it's a long way. It's getting there fairly quick, actually. Now, it's spoiled the special thing about.
It did, didn't it?
Story. Let's sort of unwind a little bit. So Alpha Centauri is the nearest star to our own sun, but it's actually what we call a star system. So the Alpha Centauri is 4.3 light years away. So the light that we would see in the night sky, it takes 4.3 years to arrive into our eyes. Now, I said it's a star system, and that's because the Alpha Centauri is actually a triple star. There are two very obvious bright stars, and those are the very stars as we approach. There's actually a third star called Proxima Centauri, and as the name suggests, Proxima Centauri is actually the nearest star to us. It's a red dwarf, and it's only 4.2-ish light years away from us, so it's that little bit nearer. So we may have zoomed past Proxima Centauri as we were approaching there. Let me see what other information I've got here. That's really good. So the two stars actually kind of revolve around one another. The magnitudes, they're pretty similar sort of stars, the two of them. One is magnitude 0 and one is magnitude 1.33, so quite similar. At the moment, the separation between the two stars, when you look at them in a telescope, is reasonably wide. You can certainly see them through an 8 or a 10-inch telescope with a reasonable amount of magnification, say more than 100 times. The separation is 6.5 arc seconds. That changes, and this sort of representation actually shows you sort of why that separation that we see, why it changes. It's a little bit like the Galilean moons. So as the two stars kind of revolve around one another, they go further apart, and then as they move on, they get closer together. I can remember a few years ago, 3 or 4 years ago, it was actually very difficult to split the A and the B component of Alpha Centauri in my 10-inch telescope. It's now relatively easy to split the two of them.
Now, I won't ask if anyone's got images of this, because I know that none of our team tonight have taken an image of this. I've
got an interesting fact about the discovery. The I mean, obviously, it's a naked eye visible star. It's the third or the fourth brightest star in the sky, or stars plural. It was discovered in the fact that it's a double star was discovered in 1689 by a chap called Father Richaud, who was a Jesuit priest. And they think that he was actually the first person to use a telescope in India. But that was discovered 80 years after Galileo.
Turns out I was wrong. Turns out one of our members has taken a photo of it. So it's not a close-up image. It is. Oh, look! You can even see the emu. So we can see. Do you want to point out the emu, Andy?
Here's its head, and here's its body going through here.
Yep.
But here's well, this is technically, I call this Alpha Centauri because it's rival, or the pointers. The bottom of the pointers, the red one. It's slightly red tinge. You can see it there. But it's a way I always use it to help find the South Celestial Pole. You can just make out the Southern Cross here. 1, 2, 3, 4. And there's a fifth one there. And you draw a line through there, and draw a line angled off here, and the South Celestial Pole is about here. Just by eye, I'd have to look a bit. And here's one of the clouds. But yeah, that's Alpha Centauri. And when you look at it through, you definitely see two stars. There's three there, but
and Linda's reminded me of a little fact in our logo, the ASV's logo. We actually have crux and the 2 pointers in our logo. So Alpha Centauri, you can see the logo just in the sort of the top right
corner.
Yeah. So the leftmost star is Alpha Centauri. The next one in is Beta Centauri, which is also called Hadar, and then they point over to the stars in Crux, in the Southern Cross. Alpha Centauri is also known as Rigel Centaurus. Interesting how they have different names.
Yes. I think now we're going to move across to, and I'm going to try and say this correctly, Steve. We're going to move across to Albireo.
Albireo, but
Albireo. There we go.
Okay.
Albireo. Is it a blue or a red biro?
Well, it's a blue one and also a sort of a yellowish one, I think.
So we're going to do something pretty a little bit different with this one. We're going to have a look at the barycenter of this object. I'm going to leave the explanation of that up to Lee, because Lee's been mucking around with this all afternoon. So we'll allow him to explain what a barycenter is, Steve. Unless you'd like to.
No, I will leave that to Lee.
I'd be more than happy for Steve too. In fact, we actually saw it in the a little bit earlier in having a look at Alpha Centauri. So pretty much a lot of objects we have that we look at, and even the Earth and the Moon, have a barycenter. The barycenter is a point between the two objects where the mass between the two objects is equal. So it's that point where they will rotate around each other. So we see here we've got Albireo B or beta and Albireo A alpha, and there's a point here at which they both rotate based on the mass or the gravity that both exude on each other. So if I just speed the time up, and again, it's just what we were sort of looking at with Alpha Centauri. So we're now looking at this at 30,000 times, or where are we? 10 to the power of 7 times faster than normal. And we can actually see that they're rotating around each other. And this here is the barycenter between this star and here. But we can actually see, if we look a bit closer, there's a bit of odd movement there. And that's because it's another binary within its own star system. So you see the two stars, we'll have to slow this down. You see the two stars here circling around each other, and they will speed up and slow down according to where they are in their path. There's the barycenter for those two stars. But again, if we zoom back out, this here is the barycenter between this star and that group of stars. So yeah, there's definitely a lot of objects. Like if you look at within our solar system, the sun itself is, or very close to the sun, is the barycenter to all our planets that surround it. There's a barycenter between the Earth and the Moon, and it's a lot closer to the Earth than the Moon. It will be closer to the heavier object. But that's pretty much what I had on it.
That's really good. That sort of built on some of the notes that I had about Albireo. Probably what we haven't explained is for those who are not familiar with Albireo. Albireo is probably the most beautiful double star to look at through a telescope. The brightest component is a sort of yellowish, as you can see here. What doesn't really stand out so well is that the B component of Albireo is a really bright blue colour. And it's really bright blue in a telescope. It's a wonderful object to look at. So it's an object that we can only see at very specific times of the year because it's a star in the constellation Cygnus, and it only pops its head above the sort of northern horizon at this time of the year. Cygnus is really a northern hemisphere constellation, but Albireo just pops its head up and will appear in the northeast and then curve its way over and disappear again in the northwest. It's in terms of it's 380 light years away, so not too far away, but it has quite a good separation. It's a separation of 35 arc seconds. Do you remember Alpha Centauri was a separation of about 6.5 arc seconds? So it's readily visible as a double. The double of the A component is not. You can't split that in a normal sized telescope. You'll have to use something like Hubble to split that, because those two components are only 0.4 arc seconds apart, and that's too small a gap to see in a normal telescope. The double star was discovered in 1681 by John Flamsteed in the UK. Flamsteed was one of the people that put together one of the early sort of star catalogues and the designations of stars. We'll perhaps talk about Flamsteed again when we're looking at some of the other objects.
I think we can move to our next object, which is our first cluster, which will be an open cluster. It's probably one of the prettiest clusters. No, you're not looking at the right list, Lee. You've got to go in order.
Oh, I didn't go. Oh, yeah.
We will get to that one.
Jewel box.
Jewel box. He's jumping the gun.
Now that doesn't turn up in here. So what's the NGC for that?
Oh,
Was it 3572 or something?
Hold on, I can look.
got me now.
It looks like
Yeah.
I used to know that one because I looked at it all the time.
Bear with me, I'll look it up.
NGC 4755.
There we go.
Oh,
4755.
different
Oh, there
one.
we go. We got some stars now. Yeah.
So we'll look at that again. What was it again? Sorry, the
4755.
4755.
Now, of course, if we had Paul Gardner on the call, we could ask him to do a full description of the jewel box for us.
Okay. Now, we need to explain this. We have obviously different sections in the Astronomical Society of Victoria. We have a radio astronomy section. We have a juniors section for the junior members. We have astrophotography. We have solar section, lunar and planetary club section. And we have deep sky section. And Paul is our deep sky section director, and he loves the jewel box cluster.
But not at
one of his favourites.
Yeah.
So what I'll just do though, because it is just slight, well, it's not faint as such, but I'll just reduce all the background stars so it becomes a bit more prominent.
Yeah.
And maybe can we brighten up the main stars in the object?
We do get. I'll probably. We get the Milky Way in the background there.
Spoiling the fun.
That's pretty.
Yeah,
It's still
pretty.
So it's a very open cluster of stars.
So if we were, shall I start talking about it?
Yes. Yeah.
Okay. So if we were at Coalfield Racecourse at the moment, the jewel box would be very high in the south at the moment. As would obviously the Crux, the Southern Cross, because the jewel box is very close to B Crux, which is the second brightest star in Crux. As you've suggested on this, it's I use the word stunning, a stunning open cluster, and it actually contains about 100 stars of different colours, and that's the reason it's called the jewel box. So so Paul has come back with a derogatory comment there.
Steve and I are getting in trouble from Paul.
Yeah.
While you're talking about this, I might just bring up an image that Andy has taken.
Great.
Of the jewel box. To give you a better idea of what it looks like visually when we look at it.
So there's about 100 stars in that open cluster there. So these are gravitationally attracted to one another. So an open cluster is stars that sit in the same area of space, if you like. It's not just a sort of an optical cluster. They're actually together in space. The different colours, I can certainly see white stars, blue stars, and an orange star. You can actually see the orange star there in the middle. It's quite a long way away. It's 6,400 light years away, this open cluster, magnitude 4.19. So it's probably just about visible to the naked eye in a very dark site. The other thing is it's a very young cluster. It's only about 7 million years old. So the stars are very young. I think you can see as well that in this image, can you see what we call an asterism, which is it looks like a capital A, and the orange star is on the bar of the capital A. So the tip of the A is up towards the sort of top right. And then that's great. Thanks for that. And that orange star in the middle is a red giant. So even though it's only 7 million years old, that will actually be coming towards the end of its life. Some stars burn themselves out very, very quickly. Our star will go for 10 billion years, whereas some of these big bright stars can burn themselves out in a million or 2 years. It's amazing.
Live fast, die young.
Yeah.
Just like rock stars do the same thing.
Yeah, that's a good. I like that analogy. These are rock stars of the astronomy world burn themselves out. Yeah. Discovered by Nicolas Louis de Lacaille, who's another character that we'll probably talk about as we go through some of the other objects. French guy. He discovered it in 1751 during a visit to South Africa. This is an object that isn't visible in the northern hemisphere. It's down near Crux. So the early astronomers sort of said, "Hey, let's go off on a bit of a trip here, and we'll see what we can see down the other end of the world." And what they found was actually a lot better than what they could see in the northern hemisphere. We're very lucky down this part of the world.
Okay. Apparently, Bill's saying I'm the rock star of the astronomy world. That means I'm not going to be here for very long.
So we give you another 12 months, do we?
Give me another 12 months and that'll be it. So, Lee, this is an image you've taken, I'm guessing?
Yeah, that was my jewel box. It's a slightly different orientation.
Yeah.
That's nice.
And well, certainly not as good as Rod. Who had that? That was Andy's one, yeah.
Yeah.
But you sort of, when you zoom in, as you can say, as Steve said, you can see that red giant right smack bang in the middle, and definitely seeing that the asterism, the A, right there.
Yeah.
Yeah. What I really like in your image there is there's another red star just close to the red giant.
Yeah, little one.
I like that.
Yeah.
Now, this is one that with fairly cost-effective equipment, again, using your phone and a cheap telescope. This is my image of jewel box through the 8-inch using the phone. This is a single click. Just held it to the eyepiece, focused it, and just pushed the button. So you can really see that A in this one, Steve. You really see. I'll have to change screens for a second so I can.
Yours is actually up the right way.
Yeah.
Is it? It could be. So you can see that.
Yeah.
I don't know if you can see the cursor there.
Yeah. What's really good again here, Mark, is that the images that you're taking with your phone are actually very similar to the kind of image that you would see through a telescope. So that's pretty much what you would see in a reasonable sized telescope.
Now I think we might be ready to jump across to the next one, Lee, which will be Omega Centauri.
Oh.
So, Steve, would you like to start talking about Omega Centauri before
the next three objects, what we're going to be looking at is the three largest globular clusters in the sky, and the great thing is that two of those are only, well, it's great if we're down here. Two of them are only visible from down in the southern hemisphere. The third one, which we'll come to shortly, would be on the horizon if you were in the northern hemisphere. So Omega Centauri is a globular cluster. So the three objects that we're going to look at now are globular clusters. These are very ancient clusters of stars. Some of them are nearly as old as the universe. So they're sort of 12 billion years old, some of them. Omega Centauri they're gravitationally attracted large clusters of stars which have sort of sped their merry way around the local universe, and over time have become attracted gravitationally to our Milky Way galaxy. And most of them sit in around the edge of the Milky Way, not inside the Milky Way, actually around the edge. Most of them in what's called the halo, which is around the sort of the edge of the core of the galaxy. So Omega Centauri is the absolute rock star amongst globular clusters. It's significantly larger than any of the other globular clusters in the sky. It has currently, they think, about 5 million stars in it. It's so big, in fact, that the new thinking is that it may not really be a globular cluster. It may be the remnant of a dwarf galaxy that is now attached to the Milky Way. So this object is 17,000 light years away, and is magnitude 3.68, so it's easily visible to the naked eye. You'll see the designation Omega Centauri. So that kind of a designation would normally be given to a star. It sits in the constellation Centaurus, and in antiquity, it was actually thought to be a star. But Edmund Halley, the discoverer of the famous comet, he actually noticed that it wasn't a star, it was a sort of fuzzy patch in the sky. And so he didn't quite know what it was. That was in 1677, so quite a long time ago. And then later on, John Herschel in the 1830s, who was using a much better quality telescope, he then catalogued it as a globular cluster. So by then, the telescopes were able to resolve some of the individual stars in these objects. So reasonable distance away, 17,000 light years.
So Lee, can we do a bit of a fly through? And then we might have a look at some of our astrophotography images of this cluster.
I was just going to say, even before doing that, like Steve, you mentioned that there's potentially millions or billions of stars in there. But what I love about this, regardless, is even as far away as it is, and with the amount of stuff in there, if I go and put the labels on, pretty much everything that's sort of visible has a separate designation to it. So
it's amazing.
It's quite. Actually takes
all the individual star designations. Wow.
Yeah.
So we go flying through.
Yeah, Omega. I actually had one of my own queries about this. Steve, I don't know if you could answer it.
Careful.
Hang on, I'll just spin back around. When sort of with the software, which I noticed someone's just asked earlier what the software was, and just to reiterate that, it's called Space Engine. So when I can change the time frame on this, and we could see when I sped up the when we were doing the barycenters earlier, you could see everything going far quicker than real time, and you see planets revolving around the sun, and suns revolving around other suns. When I increase this significantly, so we're now at the maximum time frame of 10 to the power of 12, and this is the time here, so this is in hundreds of thousands of years. It doesn't change now. Do you think that's something that's a where in the software they've they just haven't put that, or do you think would we actually say that it doesn't move? Like, is this expanding just like the rest of so many other things?
I think over time, most of these globular clusters are going to get absorbed into the Milky Way. I think. In the same way that the Milky Way and the Andromeda Galaxy will eventually come together, and the way that the Milky Way will probably absorb the Large and the Small Magellanic Cloud, I would expect that these globular clusters will eventually be absorbed in. But they're very ancient objects. So, a nice picture.
There we
So,
go.
it may be that the stars will actually come to the end of their active lives before they get to become a sort of true part of the Milky Way. I'm not sure. I'm kind of guessing a little bit.
Yeah, no, I just wondered, like, because you said earlier that they've obviously at a point where they're sort of. I wonder whether it was almost like everything has actually at some point in the very distant past found a point of equilibrium, such that they're not rotating around each other, and they're static in a way. I wondered.
Yeah. So I don't.
Right.
I would have thought that the globular cluster itself is probably revolving as well. I mean, that's sort of. I think it's physics. I think it is. As I say, I'm just surmising a little bit. I don't know if anyone out there in that's on has any more insight into that. I'm not sure.
So I think what we might do is jump on to have a look at these images that some of our members have taken. So these are some photos that Anne-Marie has taken. Anne-Marie, if you'd like to walk us through these.
Yeah, this one here, I just realised I'd made a mistake on the other one, but this one was taken with my big telescope, so it doesn't show all the outer stars. So I don't really like it. But yeah, this was taken with this.
Yeah.
Yeah, it's
nice
sort
and
of
colourful.
nice. It's sort of nice, but I did one. This one was taken in early 2020. But I've got this one here I took in January 2020, and this was with my other scope, which is an ED80. And that sort of gives you more of an idea of the stars around it. So I just prefer this one.
So this was taken with your Skywatcher ED80 with a ZWO ASI 1600 mm camera. This is 2 hours and 31 minutes of imaging.
It's blown out. So this is before I really knew how to control them. So it's not a very good photo, but it doesn't show the core very well like the other one does, but the other one doesn't show the outer stars. So.
Very beautiful images, both of them. Now, Gerald's got his one. So, Gerald, would you like to take us through what you did with this image? How you took this?
Yeah, this one's taken with my ED100. And this one, I think this one's a single shot. And it would have been 180 seconds, I think. But yeah, I was quite happy with this. I'm not sure about the green hue in it, but yeah, it's a lot of stars in there, isn't there?
And then we might jump across to Andy's version of this. His comes complete with a toilet tent and a telescope.
Yeah, I couldn't find the actual image. All I could find was my Instagram image, so I sort of put that in front of it just to. I've got it somewhere, but I've just been searching everywhere. I know I've got it somewhere, so I took this with the 6-inch Newtonian with a old Canon DSLR, and yeah, it's a little bit blown out in the core, but yeah, you can see this with the eye as clear as anything. You just walk outside, and within a couple of minutes, you can just sort of see this fuzzy patch. Probably not in the city, but out here you can. You don't even need your eyes to really get fully dark accustomed. I reckon within a few minutes you can just start to. But yeah, it's quite a bright fuzzy patch, but even binoculars you can see it quite clearly.
Naked eye as well, you can see it, can't you, Steve?
Yeah, all naked eye.
Yeah.
Just make it out.
Up at our dark site near Heathcote, you can certainly see that it's not a star. You can see it's a fuzzy patch.
Yep. Now we've got a couple of questions. Hayden Purcell is saying, often with Nebula, he shoots 300-second stubs. What is best for a cluster like this? He has a 115mm API and a 294 MC camera on a HEQ5. won't mean much to most of us. It means a lot to Andy, Steve, Lee, and Anne-Marie. They'll know what that is. So is there any advice you can give Hayden on what sort of settings he needs to image these sort of objects?
Well,
anyone?
how long did I do this? I just can't see what I did. How long I did?
What?
This is mine's a 30-second. Here we go. Mine's a 30-second single image with the Canon 450D. So that's a 30-second single image I took with this.
What's he currently using, Mark?
He's got a. Hang on, I'll pop it up for you to have a look at. Bill's saying 120-second subs. Thank you, Bill. For those of you at home, Bill is an ASV member. Knows a lot about astrophotography.
I do 120-second subs, but for these ones here where the core is so packed in, I'd probably do 60-second subs, and lots of them.
I tend to go quite low, to be honest, because they're so bright. There's a combination where though they will stack, but at the same time sometimes there's too much data, and stacking will actually throw away more data than what you would hope. So that's where sort of the longer subs do work. So it's really about experimentation and finding a compromise.
It also depends on your skies, whether you've got clear skies or city skies.
Yeah. There you go. Hope that helped you, Hayden. Now, are we still any more information you want to share with us on Omega, Steve, or shall we move to the next one?
I can kind of carry on talking while we're moving to the next one.
Okay, there's a question that a couple of the others can answer while we're moving to the next one. There's a bit of an astrophotography one.
Sure.
So Christian wants to know, what programs do you guys use for stacking multiple images? Now, I use AstroPixel Processor when I do my phone image stacking, and I know a lot of the Astro guys use it. Anne-Marie, what do you use?
I use PixInsight, which is quite hard to learn, but it's certainly worthwhile learning it. I love it.
I'm an AstroPixel Processor as well.
And what about you, Gerald?
I used to use Deep Sky Stacker, which is a free software. But I've gone all lazy now. I actually do my live stacking, which does it all for me. So I kind of stick down that path. But Deep Sky Stacker does a great job.
Yep.
So with your live stacking, what are you using to do your live stacking? What software?
I'm using the ASI Air Pro. It's got its own software which does it all for you. And all I do is just take images, one image after another, and it just does it all. It looks for the darks, it looks for the flats, the bias frames, and puts it all together for you. Does a pretty good job.
Okay, so we're now on 47 Carinae.
Can I suggest that we bring in some of the photographs that people have taken, some of the images that people have taken? I think it might help to demonstrate what I want to sort of talk about.
Yeah. Who's got an image of 47 Carinae ready to share?
I've got one up.
Oh, there we go.
There we go.
Right. Just something when I'm looking at these big globular clusters, this is the second brightest one, which is 47 Carinae. When I'm looking at these, I sometimes sort of think, I wonder what it would be like to be stood on a planet and one of the stars in one of these globular clusters, where the stars are that much closer together. Just how bright the night sky would be with stars. I wonder what it would be like. Perhaps amazing, perhaps not amazing, because you would be just sort of flared out by starlight. I don't know. But so 47 Carinae has it's another one of these globular clusters that has a star designation, 47 Tucana, but it's definitely not a star. It's the second brightest globular cluster in the sky. It's fairly close. When you look at it, it's fairly close to the Small Magellanic Cloud deep in the south, so not visible from the northern hemisphere. Again, it's not quite as far away as Omega Centauri. It's only 13,400 light years away. Magnitude 3.95, so again visible to the naked eye in a dark sky site.
Oops, sorry.
What you can really see, well, I hope you can see, compared with Omega, there's about 500,000 stars in 47 Tucana. There's 500,000 stars, and there's a hawk as well.
Peregrine, isn't it? Is it a peregrine or?
It was a peregrine.
Peregrine, he's a peregrine. Bill's saying if you're on a planet around 47 Tuc, you'd die of radiation sickness in hours. Probably would, yes.
So, but I think hopefully what you can see, if you think of the images we had of Omega Centauri, the really nice thing with 47 Tucana is that it has this very bright core in it. And it's not quite as big as Omega Centauri, but it has this really bright core. I think that 47 Tucana is a nicer object to look at through a regular sized telescope than Omega Centauri. It's probably one of my favourite objects, 47 Tucana. So it was, as I was saying about it, it was originally given a star designation by John Flamsteed, and then our good friend Nicholas Louis de Lacaille noticed that it wasn't a star, it was a nebulous object. That was in sort of 1751. And again, that was on this trip to South Africa that he did. He recognised that it was certainly a worthwhile trip to South Africa.
Yeah. Andy, would you like to tell us about your image here that we have?
Oh, yes. That's the same 47 Tuc I took a while ago. Same thing. It's on my Instagram page because I've got up hard drives and I've got a bit of a mess of images and they're on hard drives somewhere. And the best repository at the moment is Instagram because I haven't been uploading it to anywhere else. So this is the only image I've got. I've got no info. All I've got is, even on Instagram, I took it a while ago. So, yeah.
Can't wait for the clouds to go tonight. Well,
that was 64 weeks ago.
Yeah, we're thinking the same thing tonight, aren't we?
Waiting for the clouds to go. And here I am with my scope, and the dog's waiting, sitting down the bottom, waiting for the clouds to go. But that was, you can see that they're whoops. But
Gerald, your image is a wider field view of 47 Tucana.
Yeah, this was taken a long time ago. It's got my old logo on there too. It was taken with an ED-80, I think it was.
So the ED-80 is the telescope.
Telescope, yeah, the refractor. This is with the Geelong Club had used their telescope for this one, and I had my Nikon camera on the back of that. So I can't remember how long this was, but this is going back about 5-6 years ago.
Can you see, interestingly, just over to the lower left? Can you see that little fuzzy blob?
Yeah,
that's NGC 121, which is actually another globular cluster, but much fainter than 47 Tucana. So that one is magnitude 11.19 and 200,000 light years away, rather than 13,500. So that will be over the far side of the Milky Way galaxy, probably quite a way out from the core as well.
The fake 47 tuck, apparently. The fake 47 tuck's a bit further across, isn't it? It's not that one there. There is one that kind of people can get confused and think is 47 tuck. It's not that one that you were talking about, is it?
That one's this little one is
this tiny little one to the left-hand side. That's not the fake 47 tuck. There is
you can probably see the difference between the two there. That's
yes. And then we have Lee's. Which one's this, Lee? This is 47 tuck.
It's 47 tuck, but I just wanted to sort of quickly demonstrate. This is after process. It's after processing, and this is a bit of a fake kind of doing this. But if we had been doing some live stacking tonight, it would have looked a little bit like this, where we'd start off with seeing some of the brighter stars, and as each new image comes in, we start to see some more stars. And this is the same, basically the same image.
Filled the screen as we were watching and talking about it. Yep. Yeah. It's actually a really good way of showing everybody what they would have seen from the first image through to when we moved to another object. If we were live stacking tonight, it would have been a slow process. You wouldn't have seen the end result at the start. You would have seen, as Lee's saying, a dull object. Slowly it's get brighter with more and more detail, the more images that they stack on top of each other.
So yeah, and then looks that's how mine would have certainly looked, because I was saying I tend to take quicker subs, and that's sort of what mine tend to look like. With those that take longer subs, they'll sort of start off with something more like that, and then they'll still fill out, but then doing some stretching and everything, it will sort of, they'll get to something that might be what they want. This was the end result of an image, so that's how I left it when I was done. So it's a bit hard to sort of do it after the fact, but yeah, as I was saying, it's just sort of what it looks like roughly.
I've just been reliably informed by our Deep Sky section director, the man who loves the jewel box cluster, that the fake 47 is NGC 362, and he likes to trick people with it when he puts a high-powered eyepiece on there and pretend that it's 47 tuck.
Yeah, I was just looking that up in my charts in Sky Safari. So 362 is 28,000 light years away, and it's a lot brighter. It's magnitude 6.4, so a much brighter object. Yeah, it's another really nice object to look at in the telescope.
It is, but we're going to move to M22, Messier 22.
So while we're zooming to M22, so this is the third brightest globular cluster in the sky, and was just visible on the horizon from Paris, and that's why good old Charles Messier catalogued it as M22 in his catalogue of objects not to look at because they aren't comets. And the M22 is very close to the lid of the teapot, so the teapot being Sagittarius, and it's another globular cluster that contains about 500,000 stars. If we've got some images of it, one of the difference here is that compared, particularly with 47 Tucana, it's a much more dispersed globular cluster. It's actually the nearest of the three big ones that we've looked at. It's only 10,000 light years away. A little bit magnitude 5.1, so would be on the sort of the cusp of what you could see naked eye. You probably wouldn't be able to see it because it's a deep sky object rather than an individual star. Magnitude 5.1, I don't think would be visible.
Now, do we have any images? Any of the team taken any images of M22?
No.
Sure.
I don't believe I ever have.
I don't think anybody has. So you've stumped everyone on this one, Steve.
Okay. The image there doesn't really show that sort of dispersed nature. If anything, it kind of looks more concentrated, but it's actually
doesn't it?
it's actually more dispersed than certainly than 47 Tucana. This one was discovered in 1665 by a German astronomer called Abraham Isle, I think is ISLE is how it's pronounced. And as I say, it was catalogued by Charles Messier as M22, actually on the 5th of June, 1764. So one of the stars of the northern hemisphere, really. But down at the horizon, so quite difficult to view unless you've got a Coalfield Racecourse kind of a view down to the horizon.
Uninterrupted horizon views. Yes, it is actually very good out there, isn't it? Very low viewing. Not a lot of tall trees in the way, not a lot of tall buildings in the way. Skies aren't the greatest, but very good for public viewing. That's for sure. Would have been good tonight.
The objects that we've selected tonight were originally selected as ones that would be quite visible in our public viewing session at Coalfield tonight. So they're bright objects. They're good objects to view in a relatively light polluted sky.
Yeah, I think we might jump to the next one because it's going to be a nice one. Eta Carinae nebula.
So we've done our globulars.
We have. Now we're onto the nebula.
We're onto a nebula. Now this is where we really need Stefan on the call to give us a really detailed description of Eta Carinae and the Eta Carinae nebula and all that good stuff.
Unfortunately, Stefan's at a Zoom birthday party.
Yeah, so you'll have to make do with my my poor attempt. So Eta Carinae is a star, and it's at the sort of the core of it's that bright blob over to the within the Carinae nebula, the naked eye in a dark sky site. Now the star at the heart of it, which is Eta Carinae, so in the constellation Carinae, it's one of the most massive anywhere in the Milky Way, and there it is. Now I'll talk about why it's a funny peanut shape in a moment, but it's about to go supernova. It may, in its own space and time, have already gone supernova, but it's about to go. So about to go is probably in the next 200,000 years. So that's sort of like the now in astronomical terms.
With supernova, or with stars that are about to go, a star may have already gone supernova, but we won't know until its light reaches us. Is that correct?
Well, to give you an idea, that the Eta Carinae is 10,000 light years away. So if it could have gone supernova 10,000 years ago minus 1 day, and tomorrow we will see it in the daylight. So it's the light takes 10,000 years to get to us. Are you going to talk about the peanut, or do you want me to?
Oh no, I'll let you talk about the peanut.
Okay, so that little sort of peanut shape it's actually where a few years ago, not 200,000 years, a few years ago, it started to blow this gas off to the side. So it's actually the two little these sort of nodes on the side are actually called the homunculus nebula, and they're the sort of precursor to the star going supernova. It's kind of blown this gas out to the side,
almost like its outer shell.
Yeah, it's like an outer shell. Now, if we were at our dark sky site at the LMDSS, we would be able to see that homunculus nebula through our big 40-inch telescope. It's quite hard. I can't see it through my 10 or 12-inch scope. You need something bigger to actually see it.
So when we say 40-inch, what we're talking about is the mirror size. So it's a 40-inch mirror. It's effectively a 1 meter diameter mirror on that telescope that we have up there. So the telescope itself stands, what, Steve, about 3.5 meters tall?
It's something like that. It's a big ladder.
It's a big ladder, yes. It's a very big telescope. So that when we're talking inch size of telescopes, like a 10-inch telescope or a 20-inch, you're talking mirror size. So that 40-inch, there it is there. Yep, so there it is there. And there's our Deep Sky Section Director, Paul, with his back to us, getting in the way of the view as always.
So the little scope to the right is an 18-inch telescope, and the our 40-inch telescope is the big
one at the back. Yes,
like a black hole. We do have another large telescope which doesn't fit in our roll-off roof observatory. It's a 25-inch telescope.
It's 25-inch. Mikhail's right. It's the stairway to heaven. The ladder up to the 40-inch.
The ladder's actually down on the floor there at the back.
It is, yes. So it's quite a big scope.
Yes, wonderful views. The Eta Carinae Nebula. Hey, this is it's our good friend Nicholas Louis de Lacaille. God, he had a great trip to South Africa in 1751. He saw the Eta Carinae Nebula as well. And
he wasn't in lockdown, that's why.
What a great trip he had.
So, Anne-Marie, this is your image of the Eta Carinae Nebula.
I've got a few here. It's quite a nice target to take photos of. This one here is one of the first ones that I did take, and this was with a Canon 5D Mark II, which has been modified so that I get the better colour. With the scope, with the ED80 refractor again, and this is 1 3/4 hours. One of my very first ones.
So it's 21 5-minute exposures. And this one's 9 hours and 40 minutes.
Yeah, this one's was this with the other? Oh, this is still with the ED80.
Nice.
Yeah, this was just with the three filters: the HA, the sulfur, and the oxygen.
So the HA is the hydrogen alpha.
Yep.
Yep.
And that's just something that I sort of started doing a lot of these sort of colours. And then I moved on to the bigger telescope, and you don't get as much. This is just the centre of it. This is the centre of it here, the Keyhole Nebula. So this is slightly off to the side. So that's 5 hours and 44 minutes. So, and then this is one that I took the other day, which really shows the keyhole in the middle there.
It does, yes. Yep.
So that's just the dead centre. That was actually one that I started for the last live stream.
That's 2 hours and 36 minutes. The other one was 5.5 hours, and the other one before that was 9.5 hours.
9 hours.
Now that's just the imaging. That's just the time spent taking the photos. Doesn't include all the time you spend setting it up and making sure everything's working. Doesn't include all the time you spend stacking and processing. And so there's essentially nearly in that 9 hour exposure, there'd be close to a day's worth of actual work, like full 24 hours worth of work to get that image.
Yeah, for sure. But it's worth it.
It is, isn't it? It's a beautiful shot, this one in particular. I really like this one.
This is the last one that I took, but I don't know.
I
never really liked my photos, but so that's mine. I'm sure somebody else has got some beautiful ones too.
Well, let's have a look at Lee's. So Lee's focusing in on that's the homunculus and the keyhole?
So homunculus and keyhole. This was hydrogen sulfur SHO, so sulfur, hydrogen, oxygen as well. For me with this one, it wasn't even like the colours are something that you don't tend to see like this. It was just a bit of mucking around with the palette to see what sort of colours I could get out of it. But I think one of the things I love the most when you go and do the using your hydrogen filters, the narrowband filters, is how sharp you end up getting these little wisps that sort of just turn up. They seem to be in the middle of nowhere, And I think it's going to show the other one. Where's the other one? Hang on.
Got
So
another
that
one.
was it. I think this is probably my favourite one though, which was actually RGB. So it sort of shows, you know, when you're actually using. I think it was actually a DSLR actually too. So effectively natural colour, as natural as it could be.
And we've got Gerald's version. This is another one of your live stacked ones.
Yeah, it's a live stack one, of course. Yep, yeah, yeah. It's a great. It's one of my go-to images of the sky. This is just there's just so much you see in that. But
What did you
yeah,
use for
again,
this one?
I use ED 100 refractor telescope. I used a cooled camera. So I use the ASI 294 MC Pro, which I think I cooled it down to about -30, I think it was. But yeah, there's not too much noise in this image either, which I'm happy about. And you can pick up, I'm really happy with this because you can see a lot of that faint nebulosity in this image as well.
Yeah,
Beautiful image.
it's a lovely image.
And one thing I noticed too, when I do process my images, sometimes I use the luminance layer as well, and I actually put that as a separate layer, and it tends to bring out a lot of the shape of the nebula. Yeah, so yeah, I'll sort of use that to get really to get that, and also to the adjusting the contrast and playing with the histogram to get this image
To make it pop.
Yeah.
So this is Andy's. Andy, what did you use to get this?
This is still the old Canon, 12-year-old Canon 450D. It's modded. This zoomed in, so that's the image. This is in RGB. I've done.
So how many images is that?
That's probably. I think they were 2 minutes. I did a heap of 2-minute ones. That I'd have to find all the details. I haven't got probably about 2 hours. I've got a couple more. That's in hydrogen alpha. I've just left it black and white because it's But that was I reckon
that's beautiful in black and white.
Yeah, because this is how hydrogen alpha looks before any processing. It's technically red. And here's Eta Carinae, you can see it here. It's just above the emu head. If you're looking again, you can see it. You can see it with the eyes. It's another dark sky. I mean, I'm pretty lucky here to have Border 1, and I can walk out and see Eta Carinae clearly every night, except for tonight, of course. But but normally, it's a great target. Where are we? Sorry, back to the red. It's getting my colours right. It's this one's probably a bit blown out, a bit pink, but it's got a real sort of red tinge to it. Even your cameras can pick it up, and I'm doing that's a scan. That's weird. Anyway.
Well, as you guys would know, the team here would know, I'm dabbling in astrophotography, but I'm using my phone. And the star clusters are one thing, but I've managed to hook the camera up to a Meade LX90. It's an 8-inch Smith Cassegrain telescope. And this is 33 20-second exposures using my phone stacked. So these are ISO 1600. Cool. So this is Eta Carinae keyhole. This is from our dark sky site, so under some pretty good nighttime conditions. So once again, You don't need, if you've got a phone that can take raw data image, most of the new Android phones can do that, and I'm pretty sure the new iPhones can do that as well. And you have a telescope that tracks. Doesn't have to be an expensive tracking telescope. Mine's not a fancy one like the astrophotographers use. You can do this, and it's a lot of fun. It really is to be able to do something like this with your phone. It's not as good as the other guys, that's for sure. But the fact that this has been done with a phone, the camera on a phone is pretty impressive. It sort of says that if you're interested, it's a good place to get started. A good place to sort of like test the waters and see if you're interested in astrophotography, and then start to spend the money on the really fancy equipment. The fact that I can image this from my backyard in Melbourne as well. It's not as good as this, but it's still pretty good using a phone camera. Now, I think we're moving to the next object, Lee, when you're ready.
So, M6, I think, Lee.
M6. We'll jump across.
So the next couple of objects that we're moving to, in fact, the next three objects are fairly close to the teapot, so the constellation Sagittarius. And they were all objects that Charles Messier was able to see from his observing location somewhere in Paris, but fairly close to the horizon. So they sit pretty middle of the sky as they come over, but they're now that's interesting. Okay. It's called the butterfly cluster, M6, but this are we on the right? Yeah. Let me turn some of the star magnitudes up a bit.
Yeah, that is it. It's just a matter of maybe putting the rest of the stars in there. But it seems to be missing some.
Yeah.
Need to face Earth again.
We'd have to see it sort of as we see it from Earth. So I'll explain what it is. I don't know if anyone has taken any images of the butterfly cluster. So it's
we're back at Earth.
There's Earth. At the moment, if we were looking at it from anywhere, but at Coalfield Racecourse, we would see it in the east as Scorpius and Sagittarius are rising up in the sky in the winter months. And the butterfly cluster sits fairly close to the sting of Scorpius. It's an open cluster, and it resembles, believe it or not, the outline of an open-winged butterfly. When you look at this through a telescope, it's pretty obviously an open-winged butterfly, but unfortunately, it doesn't really look like an open-winged butterfly as we're seeing it there. It's 1,600 light years away, and it's magnitude 4.19. So you could probably glimpse it in a very dark skies like naked eye.
Just trying to see if any of our team have imaged the butterfly cluster, and I don't think they have. I don't think anyone's got an image of the butterfly cluster that they've taken. Okay. Astrophotographers don't like open clusters.
Yeah, I actually tried to look at it when we had the big astronomy a couple of weeks ago. Mark, I tried to get it, but as you said, they're not that fantastic from a photographic perspective.
These are really good visual astronomy objects.
They are.
And again, really good to look at in a fairly light polluted sky. Perhaps, Lee, what we could do is move on to M7, which may come out a bit better, I don't know. And I'll keep talking. So M7 is, as the name suggests, is another of Charles Messier's catalogued objects. It's an open cluster. It's actually commonly known as Ptolemy's cluster because it was mentioned by, I think, I don't know whether we could actually see Ptolemy's cluster there in the distance, but because it's pretty close. But anyway, let's see. So Ptolemy's cluster is a very large open cluster that is definitely visible to the naked eye in a reasonably dark sky sight. Interestingly, the current thinking is that Ptolemy, the Greek astronomer, actually not only did he see Ptolemy's cluster, which is M7, but he also got a glimpse of the butterfly cluster, M6, because they're pretty close to one another in the sky as we see them. So this is another one that doesn't come out particularly well in this program, and probably because it's such a big, wide, open cluster. I doubt if any of you have taken any pictures of it. Would be right there.
So as you said, I think Earth's sort of back behind us. If you look here, as you said, so the butterfly is there, and Ptolemy's Ptolemy here. So as you said, definitely would have seen the two of them.
Yeah. So not to worry. Not to worry. We've done well so far.
Oops, going back to wrong one.
Yeah.
We're going back into hyperspeed, are we?
Yep.
It's very, because it's such a wide open cluster, I think it's a bit hard to show in this program, but you can see that there's a sort of grouping of stars there. These are, I'm just looking how far away they are. So the butterfly cluster is 1,600 light years away, so it's not around the corner. The Ptolemy's cluster is 980 light years away. So again, not exactly our near neighbour. But it may be best to move on to the next object, which I think I'm expecting there will be some good pictures that you've taken of this, which is
Lagoon Nebula.
I think the Lagoon Nebula is another favourite of astrophotographers.
Oops. Lee's just trying to get in some shameless self-promotion there.
No.
This is not Lagoon Nebula.
No.
Oh, hang on.
That's M22.
Should be 6656. What did I type? Oh,
Yeah, that's
sorry.
M22. That's M22.
Oh, okay. Sorry. Yes.
Can't take you anywhere, can we?
Yeah, I doubled up on my thing. So what we'll do is we'll just fly through this to get there.
Lagoon Nebula is 6523.
And we'll speed it up a little. Keep forgetting to take the accelerator off when I get there.
So M8, the Lagoon Nebula, is another object that's in Sagittarius and sits fairly. Remember, M22 was close to the lid of the teapot, just below. This object is kind of just above the lid of the teapot, and it's a giant glowing cloud of interstellar gas. I think some of the pictures that you guys will have taken will show a bit more detail of some of the sort of the dark and the light parts of the nebula. So it's sort of split into kind of two parts with the. I'm never quite sure whether the lagoon is referring to the light bits or the dark bit down the middle. Any thoughts on that?
I think it might be the light bit there in the middle there. Yeah. Now, just quickly before we get too far into this, Bill has actually sent me a Ptolemy cluster image. So
awesome.
If I can find where it is, where he has sent it to, where have I put it? Hang on a second. We'll try and get it open.
interesting to see. But Ptolemy's cluster is, because it's such a big, wide open cluster, it's actually best viewed through a very low power eyepiece, or perhaps even through binoculars or a finder scope.
Trying to find it now. Where's he put it? It's a matter of where I've saved it in downloads, hey? There we go. All right. So let's get this shared across. Chrome tab, window. Hang on, I'm going to have to do it a different way. Let's continue on with Lagoon, and I'll bring it back shortly.
Right, okay, I'll keep talking. So back to the Lagoon Nebula. The interesting thing is the sort of history of discovery. Can you see over to the left of the nebula? There's fairly obviously a cluster of stars there, as well as the nebula itself and the dark area. So back in 1654, a chap called Giovanni Battista Hodiana, he saw a nebulous patch in the sky. So he kind of recorded it as a nebulous patch. And then in 1746, a chap called Philippe Lois de Chezeaux identified it as a star cluster, which is the bit that you can see to the left. And then it wasn't until the year afterwards that in 1747, that Guillaume Le Gentil, so William the Gentle, he actually saw both things, saw the cluster and the nebula. And then Charles Messier, a few years later, 1764, catalogued it as the Lagoon Nebula, so as a nebula M8. So it's an interesting history, and I think it shows you, over that time, as the telescope kind of changed and improved, people were able to see different parts of that object.
So Lee, this is your image, obviously.
Yeah.
Yep,
actually, it's funny. Even just mentioning those clusters, Steve. That's actually what I use whenever I image Lagoon.
That's what you look for?
Yeah, they're really bright. So when you're trying to line it up perfectly, you can actually drop your exposure even on your main scope quite low, even to sort of 2 or 3 seconds. Put the exposure up. The exposure low and gain up a bit, and line them up just so you've got that cluster. Sort of, if that's where you want it, then you put that cluster right there, and because you can't always rely on the guide scope, sort of for the spacing. And then just they are significantly bright.
I use the 2 stars, those 2 stars. Yeah. So I'm going to jump across to Anne-Marie's image here. So this is Anne-Marie's one that she's taken of Lagoon.
That's beautiful.
I have to unmute you.
Sorry.
Whoops.
Stop doing the dishes.
Yeah. We could hear dishes banging around in the back.
This is one of the first ones that I took, which I absolutely fell in love with this particular target. So this is on the old ED80, and this was taken with the ZWO ASI 1600. And this was, 60-second exposures in H alpha and O3. So no LRGB in there at all.
Now, LRGB, that's luminance, red, green, blue.
Yep. So none of that. I've got a couple here. So that was the first one that I took. And then I took this one also with the same equipment. And so this was 8 hours and 32 minutes. And then this one I actually finished today. And this was
nice.
It's actually not finished. It's actually a mosaic. This one's on my big scope. So it's actually 2 photos. So down the middle there is where on the right-hand side is what I call the bottom, and on the left-hand side is what I call the top. And so that's in HA and oxygen as well. But I've also shot LRGB and sulfur. So I've just got to finish processing, but yeah, I couldn't do it all today.
Now, how do you stitch those together?
In PixInsight. So it's got program that...
So the program does that for you?
Yeah, sort of.
Yep. Yes. So it knows where stars are and it lines everything. And,
yeah, and it makes templates so that you can line them all up properly. And yeah, so it's a similar sort of field of view from as the other one, but it's got way more detail in this. So I was quite happy with this one.
I'll jump across to Gerald's Lagoon, which is looking absolutely stunning.
Ooh.
Very pearlescent, isn't it, this one?
Yeah, very opaque. Yeah, this one, I've got myself a dual band filter, which is both hydrogen alpha and sulfur in it. I'm not sure what the grade of it is, but it's the entry level filter. But yeah, this is taken with a 294 MC Pro ZW camera on the ED 100 refractor scope, and once again, this is all live stacked.
So this is this one you did yourself, or is this one we did from the other stream the other week, or?
It's, I can't remember now. It probably is a remnant of that. Yeah, and just put into Photoshop, and just, I think what I've done there is just adjusted the tone and the histogram on it to bring it up a bit better.
I think we might jump over to Ronnie Biggs. So this is Andy's image. So Andy, tell us a bit about this one.
Now this was taken a little while ago. I think it's about 3 hours with my Canon. Same again, Canon with my 6-inch Newtonian, and there's another one here. This one's a bit more cooked. I've overcooked it a little bit. It's a slightly different angle, but you can see all the what I call, I think they're Bok clouds. All these. I mean, I'm sort of zoomed in a bit, but yeah, just for. But I tend to get blown out stars because it's the DSLR's what happens, and because it's modded, you get that. But what I can't see the lagoon. I see I'll go back to this one.
Oh.
Yeah.
Now,
once you see this, that's what I call it. I call it the Homer Nebula. Right? Sorry, guys. Once you see that,
it's the Homer Simpson Nebula.
You'll never see it.
Now all I can see is Homer. You've done it to me.
I'll never look at that.
It is no longer the Lagoon Nebula.
It's the Homer Nebula.
Oh, yeah.
Well, the other one that I thought of, like, I think I saw Homer there as it is, but when you last showed the drawing, I was thinking more the Moai on Easter Island.
Yeah. Oh yeah, that's it. Yeah. Yeah, sorry about that. Yeah, but it's a good spot to view, because just up a bit, it's the Triffid, just around they're two very close nebulas to look at, and
there's some great objects to look at in that part of the sky. It's really good. There's a whole sort of chain of nebulae that sit off to the side of Sagittarius.
Right, sorry. Yeah.
That's there in Leo.
So that's once again, that's the fancy equipment, and then we've got the phone attached to the 8-inch Meade. This is actually from my backyard. So this is from Bayside, Melbourne.
Yeah. Now this is really interesting, Mark, because
very much what you'll see at the dark sky site visually, isn't it?
Yeah. The other thing as well is that the lagoon. I've just, while you've been showing the other objects, done a bit of research. And the lagoon isn't the bright bit, it's actually that dark line
the dark lane
splits the bright bits in half. And in your image, the lagoon really stands out.
So that lagoon, hang on, let me jump across to that. I have to jump out of screen. So we're talking about this bit through here.
Yes.
Yeah. So that's the lagoon there.
So because if you think about this, when people were looking at this object, a couple of 100 years ago, it was all visual. The cameras hadn't been invented. So that's more like what John Herschel and the others would have seen. And that dark lagoon is so much more obvious in that visual view.
So that is hang on, how many images is that? Where is it? 30 images, 15 seconds a piece.
Wow.
And that's from my backyard in that'd be Bortle 7 skies, so not very good. They're sort of inner suburban skies, and that's the phone attached, obviously, to the tracking telescope as well. Now we've got a question. We have a question. Mikhail wants to know what kind of magnification is used for these typical nebula images relative to the OTA focal length. This is one for the astrophotographers, I think. Who'd like to take that one?
Okay. Mine's a 750 mil. So it's focal length here. That's so.
I can hear you doing the maths in your head.
Yeah. I can't think of that quick. That's focal length. What
about you, Lee?
I'm trying to math it myself. I think it's in relation to so mine changes because I've got a focal reducer and so I've got a focal reducer of 0.7 magnification, and it's an f10 8-inch scope, which is 2032, which means 1422 focal length. So then I have to think of what the magnification is from there.
And then you sensor size too. Then you've got that.
Correct. Yeah. So and even that differs because if I go from the mono camera to the color, then it's different. Or if I also go to the DSLR, which is twice, which is 5K pixel size, so sensor size. Sorry.
What about you, Anne-Marie? Can you add anything to this?
Sorry, no, I'm not technical.
You do what I do, don't you? You just go, I've got a telescope, I've got a
telescope and I've got a camera.
Yeah, that's me. Some of my photos are upside down and probably inside out, but it's just, look, I do it for fun.
Same
so
here.
Not fussed about the focal.
Same
here. I know it's an important part of what a lot of astrophotographers do. Gerald, are you able to add anything to this?
All I was going to say is there's a thing called Astronomy Tools. I don't know the website, but you can actually enter all your details of your equipment, and it'll give you your magnification. So I can't answer it either, top of my head.
All right. I feel like this is where we need Nolan or Neil,
Yeah.
One of those two. But Bill's given us a bit of an answer. His nebulas are pretty large, so you want a short focal length. If anyone needs a telescope, Bill's your man.
That's why I had to do that one in 2 shots because it was too big.
And that's the reason why even on my the Edge HD 8, the 8-inch scope that I've got, something like Orion M42 or Eta Carinae doesn't fit in it. So I have to use the that's why we got the 0.7 reducer, and even then Eta Carinae still doesn't fit in it. But what happens if I look? That's with the mono or the color one-shot camera. But if I go to the DSLR on the same setup, I can get all of Eta Carinae in because the sensor size is larger. So it as I said, it changes all the way through depending on what you've got. So a lot of our images are really, you go to do an image, and as Anne-Marie said, if you can't take it but you really want to take it, you'll stitch it. You'll take multiples at the same focal length,
then
and
stitch
just
them together.
shifting across a little bit. Yeah.
So I have had a message from the almighty Paul Gardner from Deep Sky Section Director. From a visual point of view, and Steve might be able to back this up, he's saying to use a low power under 100 times magnification when you're looking at nebula.
Yeah, I was thinking of chipping in exactly that. I normally use something quite low, about 40 or 50 times magnification. So, you know, in my 10-inch or 12-inch f5 telescopes, I'm using something like a 20-something mil eyepiece. If I come down, so that gives me about 40 or 50 times. I have a 19 mil panoptic eyepiece, which is my sort of favorite. That gives me about 50 or 60. That works well. If I go up to the higher powered, you lose, you know, most of the nebula you can't really see in the field of view, unless you've got, you know, one of the really expensive 100-degree eyepieces.
All right, I think we're ready for the next object, which is the first and I think our only galaxy for the night. But I think we can always add some more in if we want. It's entirely up to us. So.
Well, this is, and the reason is because you know, the galaxies are a lot further away, and so most of them are hard to see at Caulfield. In fact, the final object, this is probably, well, I think it'll probably be the last object, which is another Messier object. It's the Sombrero galaxy. Is quite a challenge to see at Caulfield. You kind of have to know where it is. This is so. If we were in the field at Caulfield,
I think we're going to go to warp 9 here, Steve.
Oh yeah, I think it'll have
we're about to go to warp 9. No.
So in terms of where we're heading from the field that's interesting. That's a good view of it, actually. From the field at Caulfield, the last three objects that we were looking at, particularly the Lagoon, was over in the east. And now what we're doing is we've come right over the other side of the sky, over to the west, where the constellations Virgo and Corvus lie, and will be setting in another hour or two. So the Sombrero galaxy, this is an interesting view of it, and I'm sure we're going to have some pictures that the other guys have taken. The Sombrero galaxy is it's another of our favourites. It's quite a small object to look at visually, but it's a galaxy with a large central bulge and, as you can see here, a prominent dust line. It's magnitude 8.12, so it's quite a dim object, but it is 28 million light years away, so you know it's not going to be dead bright. It was discovered by Pierre Michin in 1767. I think Pierre was one of Charles Messier's mates. Interestingly, its designation is M104, but its common name is the Sombrero galaxy because it looks like a sombrero hat with that dust lane and then the sort of bulge in the middle. So the interesting historical thing here is that Messier made a note of the object, I think after Pierre Michin had told him about it, but he didn't actually include it in his original published catalogue, which only had 100 objects in the catalogue. But he actually recorded it in his notes. And then in 1921, the notes were actually rediscovered by a person called Camille Flammarion. And an additional 10 objects were added to Charles Messier's catalogue to bring it up to 110 objects. And this wonderful galaxy, M104, is one of those additional objects. The dark lane, though, wasn't observed until 1784. by William Herschel, who was using a much bigger telescope by then.
I think we might take a look at some of our team's images here. We might start with Andy's. So, Andy, tell us a little bit about this.
Hi. Yep, I took this. I'm just looking here. Where are we here?
Back to Instagram.
Back to Instagram. I just 2 hour, 24 5-minute subs. So 2 hours. I'm back to the image. I found the image as a JPEG, but yeah, it's. I should get a better filing system.
You probably should, yes.
You know, and put them up to
Can I just say something there, Andy? Your image, and Steve will back me up on this one. When you're visually looking for this object, you've got those 3 stars in the top right corner there.
Oh, yeah.
And when you find those 3 stars, you know, don't you, Steve? You know that Sombrero is there. It's kind of like a pointer towards Sombrero.
Yeah. When we do our star hopping from the star, let me just look. I've written this down. So the eastern star in Corvus is called Albireo. And what I normally do when I kind of do the star hopping is I go to Paul Gardner's triangle within a triangle. Yes. That's the first place I go to, and then I go to what I call my little blobby patch, which is that group of stars. Because in the finder scope, you can't see that they're individual stars. It's like a little patch of blobbiness, and you know that you're pretty close to the Sombrero galaxy, and then you can just nudge the scope over that extra little bit, and then hopefully the Sombrero galaxy will appear in the eyepiece.
Yeah, that's how I find it as well.
It's a good one, isn't it?
It is.
No,
it is.
I'm just looking at these stars. Now, they're all blown out to one side, so that's a collimation issue, I think. But this
Is that what that is? So I've been having that issue recently, so maybe that's what's wrong with my scope.
Yeah, it's a collimation issue, definitely. It's just it's all to one side, so yeah. I know they get a bit blown up, but the bright stars are all flaring to one side. Everything else is reasonably sharp. So it's only it's either that or. But I just read here. I did this during a bright moon, taken last Wednesday night during a bright moon. So it could be reflection inside the scope too from the moon hitting it. That's another issue, but I think it's collimation on this one.
Now I've got Gavin, who's an ASV member, telling me he sent me his version, but Gavin, you haven't because it's not in my inbox. So
there's some. It's an interesting object, the Sombrero galaxy, because there's some debate going on about what kind of galaxy it is, and it was thought to be a spiral galaxy. So we're seeing it edge on, obviously. But there's now some thinking that it's actually evolved on from that to become an elliptical galaxy. But it's sort of somehow managed to grab at this big dust line as well, which you wouldn't normally see in an elliptical galaxy. So that I don't think that debate is over as yet, but it's interesting.
So this view here also from Anne-Marie, this shows those 3 stars sort of pointing towards it as well. A little cluster there. There's a very crisp image for such a wide view of it as well.
That's taken with the refractor again back in April 2020.
That was like just the beginning of lockdown.
Yeah.
The first one. Now we're in our 5th.
I must have just had it out there for some reason, and then this one's taken with the bigger scope, March this year.
Oh, beautiful.
So 4.5 hours on this one, LRGB. Really.
Wow.
To see those dust lanes there.
It's good, isn't it? You can see
I still want a big.
granularity.
Go on.
I'm done.
Oh, wow. The detail in that is astounding.
See the other little galaxies up here?
Yes,
Yeah,
yeah.
a lot of little, and another one down the bottom as well.
Yeah, little
There's
spiral.
3 down the bottom there. So they're called fuzzies. Why do we call them fuzzies, Steve?
But they're sharp there.
Oh no, that they look sharp. There's quite a lot of galaxies in there.
Sharp fuzzies.
There are so many fuzzies in there. So Steve, why do we call them fuzzies?
Well, because when you look at them, they're fuzzy.
Little fuzzy blobs. You look at them and go, "Is that a star?" No, that's not a star. That's another galaxy. Now I think we've got. Here's another nice version of it. This is Gerald's version of it. So it's the light stacked version.
No, this isn't. This one was taken a long time ago. This was when I went up to Warrumbungle Observatory, and I was able to put my DSLR camera onto their really big scope. I think they've got a 24-inch scope up there.
So that's the Warrumbungles. That's near Siding Springs Observatory.
Yeah, nearby. Yeah. And I was able to put my camera on. They allowed people to put the camera on there, and I took a heap of shots, and I would have taken about, I'd say, 10 shots, and I don't remember how long.
Is this a single shot, or is this a stack?
No, this is a stack. This would have been about 10 images I took, and I stacked it at home. So, nowhere near as good as Anne Marie's.
Yeah,
I think this is a bit out of focus. Yeah, do that. Yeah. And blow it up. Blow that up again, please. It's
So now there's those fuzzies that you can see off to. Actually, go to the sort of bring it down to the lower right. Other way.
Down, but to the right.
Right.
Down, but to the right. Okay.
Your left.
Yeah. So you see that galaxy there.
The big spiral one.
Face-on spiral. This just to give
another
you
one down there too.
That's 1,400 million light years away. And that's that's magnitude 16.65.
So what you're saying is Anne-Marie's image has captured the light from a galaxy that is 1,400 light. What do you say? 1,000?
14 million.
14 million light years away.
1.4 billion.
Yeah, 1.4 billion.
1.4 billion.
Yeah.
1.4 billion light years away. That galaxy is.
That's one of the furthest I've seen.
Yeah, and you've captured that where you can actually see the spiral arms.
Yeah.
That's amazing.
That's incredible.
And the one that's further out to the lower right there, I've not got the distance, but that's actually another magnitude dimmer. So it's magnitude 17.63.
Oh.
Now, to give you an idea, for people that don't know, so the Pluto, which is a very difficult object to find, is about magnitude 14. So this is 3 levels of magnitude down from that. A typical 10-inch telescope can see down to about magnitude 14 in a very, very dark sky.
Yeah,
so
you won't see these if you're looking at Sombrero, though, because Sombrero will the light from Sombrero will block them out. Yeah. So the fact that we're able to see these in his image in that clarity is quite stunning.
Yeah.
So I can see those 2, plus there's another 2 there and another. I reckon there's nearly a dozen or more, another dozen galaxies floating around in the background on this image.
So these are almost certainly part of the Virgo supercluster.
Yep. So we've got a question, and this one's for Anne-Marie. The Sombrero picture, so your picture says that it's a modified Newtonian.
Yes.
What is modified
carbon fiber?
About it?
Carbon fiber.
Okay, so what does the carbon fiber do?
It takes some weight off it. That was the main reason I did it. We also it's been flocked on the inside so that I get no reflections. And I also got a new spider put on it as well to hold the secondary mirror, which and there was something else I did too. I can't remember something else I did.
Can you explain what the spider is?
That's what holds the secondary mirror, which is the first point of light.
at the top of the telescope.
Yeah. And then from there it goes down to the, I don't know, I'm not real technical. It goes down to the big primary mirror at the back, and then it comes back. So I don't know what it does. Somebody else explain that. I just know how it works.
All right, so
There's an image of it on screen on my side.
let's have a
Not
look
mine,
at that.
but
That's it.
so yeah. So your light comes in from here, all of here, goes down
That's
to
right.
the primary mirror, and then on the back of this is the secondary mirror, and then that goes up to your eyepiece or your camera. So one of the common things you get with Newtonians is because you have to mount this mirror somewhere, there's either a single line coming here, or for larger scopes to keep this stable, I suppose is the best way to put it, you have the spider, which is a very thin set of metal to hold it in place. And what it tends to do is you get the brilliant star sort of, what is it, like a starburst. So you get 4 lines coming off most stars as a result of that.
All right,
You can actually see someone's collimating on this one because there's a laser there.
so Anne-Marie, Bill says you get image of the night award, and I
I saw that.
absolutely
Thanks, Bill.
agree with him. Yeah. So now I'm going to. I've been sent. Gavin has been bombarding my email.
Oh, so he did send one.
His image of M104. So Gavin, you're going to have to put it in the comments section as to what you did, what the stats of this image are. But this is.
Are you saying the email from Gavin got through your spam filters?
Finally, 3 emails bombarded my email in one go. So this is an image of. So Gavin, for those non-members, the public watching, Gavin is the. I guess the property manager of our dark sky site. He's the man who lets you in and out of the site. He also looks after our remote telescope that's in a dome up there. So he's in control of teaching people how to use that dome. And I'm assuming that this image has been taken using our dome at our dark sky sites. That's all I've got on it. But it's another nice, beautiful image of the Sombrero. Not as good as Anne-Marie's, but still very good nonetheless. And this is an image I've been trying to take with my phone using the telescope at our dark sky site without success at this point in time.
You can still see those galaxies.
You can, yes, you can. I might try and somehow zoom in there. There's one there.
Yeah, there's a load of them. If you keep looking, there's more.
Yeah, there's another one here.
It's amazing.
There's one over here.
Yeah.
I don't know how to. Here we go. There's another one down there.
That's the one that's magnitude 17.5.
That one there. Yeah. So there's that one there, and then there's that one, then there's that one. Then there's this one here, and then there was some more on
There's a
this
load
side.
up there.
Yeah, I can't quite see them in this, but in Anne-Marie's I could see lots more images, lots more galaxies. It's a very nice image there, Gavin. Very nice image. So that's from the ASV's equipment up at the dark sky site. We have a telescope set up there that hopefully will be able to be used remotely from, anywhere in the world really soon if we can get things sorted. That'll be good. I think that's our last image or our last object, and unless we want to just throw in a couple of the old favourites before we finish up, I'm not sure if we want to maybe go to something like Orion or something like that to finish up. I know it wasn't on the viewing list and it's not up at the moment, but it's. I know that Anne-Marie and I know that Steve. Sorry.
Has anyone got a good image of the Tarantula Nebula?
There's a good one. We could go to
Yeah.
Tarantula. Yep.
Yeah.
All right. We will finish on Tarantula Nebula. So we'll jump across to that and have a look at that and have a chat about it and Yeah.
I've got a couple here.
So, Lee, would you like to jump us over to Tarantula Nebula?
Yes.
Yep.
Don't like
Oops.
that one. Yes.
Oh, 3370. No, hang on. I've drawn a blank.
Do you want the number?
Yeah, it's
Hold on, let me.
2700, isn't it? No.
Bear with me.
I'll let you guys argue over that.
It's
2070.
Before I tell you, it's 2070.
2070. Yeah.
Yeah. Oh.
There you go. Oh, we just drove through a galaxy.
Yeah, right through that one. So we'll just fit in there a bit quicker.
That doesn't look like Tarantula Nebula.
Doesn't, does it?
Is that
Finally get a cluster looking right.
It's a cluster.
absolutely not Tarantula Nebula?
2070. You got the right number.
It's
Yeah.
absolutely NGC 2070.
I mean, it's
No.
They are the stars that are within the Tarantula Nebula.
that's right.
It's
Yeah,
not showing
so
any nebulosity.
correct.
So let's look straight at it. We'll jump across to Gerald's image. So this is Tarantula Nebula.
Yep.
So Steve, tell us a bit about this one.
Oh, this is off the cuff. I haven't got this one recorded, but I can give you a few comments about it. So this is a truly spectacular object. This is in my top three, I think. The interesting thing about this is it's very easily visible. It's in the Large Magellanic Cloud. So all of that stuff that you can see sitting around the Tarantula Nebula is other sort of star-forming areas, nebulosity, star clusters that are all in the Large Magellanic Cloud. Now, the interesting thing is that the Large Magellanic Cloud is one of two reasonably large satellite galaxies that sit just off the edge of the Milky Way, and probably will get absorbed into the Milky Way eventually. The Large Magellanic Cloud is about 160,000 light years away, so it's quite a long way away. You can see. To me, it doesn't really look like a spider. I think it looks more like a sort of a rosette. But I think the tarantula part of it is actually the dark lanes. I kind of think, I'm not sure, but perhaps someone else has a thought.
To me, the spider part of it, as I like to describe it, is it's almost like it's the center core is the body of the spider, and all of the, I guess, the nebulosity, that almost like its legs, like it's on its back, dead, upside down.
Mm.
That's how I see it anyway. I'm not sure if anybody else sees that, but I almost like, when you see a spider on its back dead.
Yeah,
It looks like a squash spider.
Yeah, like a dead spider. Right? That's how I see it anyway.
Yeah. So this object's 160,000 light years away. The Orion Nebula, which is another fantastic object, is about 1,000 light years away. If this object were as close to us as the Orion Nebula, it would probably cast shadows in a dark sky site. It would be so bright in the sky. I love it. It's a fantastic object through the big telescope, our 40-inch telescope, but it's also a really great object through an 8 or a 10-inch telescope as well. So,
Gerald, do you want to tell us a little bit about your image, how you took this image, what you used equipment-wise?
Once again, it was the ASI, the trusty ASI Pro live stacked, and once again, put into Photoshop and played around with. Really, that's basically it. I used a ED100 with the focal reducer. I think it was 0.8 reducer. That's what I did.
All right, so we'll jump across to Andy's.
Hey, Mark.
Yes.
Guess who discovered it and where?
Our little French buddy.
Nicholas Louis de Lacaille.
South Africa again?
South Africa in 1751. What a great year it was.
Great year for junkets.
He did a lot. So, Andy, tell us a little bit about this image.
This is captured with my Canon again, DSLR. It's heavily cropped because it's quite small, my DSLR. So it's that's in with my Newtonian. But I've got an image I took. It's a Milky Way, and there you can see the emu head, of course, and the large Magellanic Cloud, and you can just see the tarantula just there. Just in this Milky Way, this was taken, just sort of see it up in the top corner. But yeah, it's hard to get the colours right with the tarantula. I can see here I've got probably a bit too much red I've put through it, but I tend to play with the colours too much, and really it's more. I've seen some brilliant. The only thing I haven't done with this one is hydrogen alpha yet. That's one day soon. I'm going to hit that with quite a few hours, but this one's only 2 hours for me, and I think they were about 3-minute subs for this one.
Who's
That one's
So this is
mine.
Anne Marie's image, and she's, as usual, just going to blow everybody's mind. The detail in this is crazy. Right?
I was just trying to look up. I knew you were going to quiz me about how long it was and all of that, and I've got no information on. I have to look on Astrogan
How many
see.
days of imaging did you spend on this one? I mean,
No,
look at
I
that
didn't.
core.
Give me a second, I'll tell you. So I think this one was started after one of our live streams as well.
Oh, really?
Yeah,
You just got
so
bored
it's
and kept going.
yeah. So yeah, it was done in June, and it was done with HA and RGB, no luminance. So I used the HA instead of luminance. And it was a total of 1.5 hours.
Is that all? Oh my goodness.
Yeah.
The detail on that is.
But I like this up here, is like little holes
that's
and
good.
Yeah.
Looks like a
There's
heart.
a lot.
It does.
It's easily one of the best images of tarantula I've seen. That. And as Steve said, visually, it's a beautiful object to look at, especially through our 25-inch and our 40-inch. When you have the O3 filter on it, it really pops and has a real 3D feel to it.
Yeah, it's great.
So, once again, for those of you who don't have fancy equipment, if you have a cheap tracking telescope and a phone, this is what you can do. This is my version of tarantula with my phone. This is 15, 20-second images taken at the dark side site.
Why is there no colour, Mark?
Because I don't know. I'm still learning.
That's strange. But your other photos did have colour.
Yeah, I know. Yeah, absolutely. I understand that. This one, for some
that's
reason,
strange.
this is how it came out. It might be a processing issue, but look, all I can say is it's a beautiful image of tarantula from the phone.
For sure.
Yeah.
Again, it's a good representation of how you would see it visually in quite a large telescope, and you wouldn't see any colour visually. That the colour is only when you take obviously the longer exposure.
You get some green through the 40-inch.
Yeah.
And the 25, but the smaller scopes you don't get that colour. But that's through the 8-inch, and once again, it's not an expensive thing to do. The phone, well, it makes my phone calls for me, and it doubles as an astrophotography camera, and it's a little bit of money on a 2-star aligning tracking telescope that was secondhand. So it's nowhere near what Anne Marie's doing, which is this amazing stuff.
Wow.
It's quite impressive. And then Gavin has shared with me an image that he took using, once again, the A's. Oh, no, that's not it. That's not the right one. Let's stop that. Let's try that again, shall we? Oh, that's all of us. We don't want to see that, do we? I think that's the one we want. Okay, there we go. So that's from the LNDSS camera and telescope, which is the 10-inch carbon fiber F5 from our dark sky site using the equipment that we've got up there. I think that's a pretty good, I mean, it's got some colour in it, Steve, but that's a pretty good representation of what you'd see through the 40-inch with the green.
Wow.
Yeah.
So there we go. I think that pretty much does us for the night. We'll bring our ugly mugs back on screen and thank everybody for tuning in.
I think we actually had one special request.
Oh, we did. Shall we do that?
Yeah. Well,
You
just
wanna would you like to get that up?
yeah. Hang on.
We will get in trouble if we don't share this. So we'll jump back on the stream. We'll come back in a second. Linda, who runs our social media.
This is basically a something kind of close to us.
It is. So Linda has been nagging all day while we've been setting this stream up that we have a look at this tonight. And I keep telling her she wants to know who she is. She should look in the mirror. This is it's an asteroid. It's I call it Who Am I? I'll let Steve try and say the actual name of it.
Hawaii.
Umama. I call it Who Am I?
Who am I?
Who am I? Yeah.
Who am I?
Who am I?
Hang on, I'm trying to get there.
Now this is
Very elusive.
we landed a probe on this asteroid, did we not? I believe we did.
I'm trying to find it.
There it
There
is.
It's trying to hide. Yeah, it's trying to hide.
Go
It's
back.
trying to hide.
It's very dark.
No, it is there. It's absolutely there.
Other way.
Yeah. No, it's what it is. It's
Have you set the time up?
Yeah.
There we go.
It's time. Okay, so let's go over here. Whoop, 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 whoop.
So when can we photograph that one?
I don't know. You should check it out.
Mm.
Oh, it was Hayabusa. We went and we had a probe on. That's right. Not Who Am I? Well, and I'm pretty sure that's not how you say it, but
It's got a couple of craters there, hasn't it?
it does. Maybe we should send a probe to this one. So, Linda, there you go. It's there for you.
Let's try to do a
Lost
flyby.
in space.
Steve, do you have any information on this object? On this?
Well, I did a search on it and it came back with nothing. So but
Nothing? Yeah.
I didn't go to Dr. Google. So keep zooming.
It was man-made for sure.
Yep.
Yeah.
It's a log in
Totally.
space, isn't it?
It's a log, yeah.
Log in space.
So all
It's
I
only
know
6 kilometres long or something, isn't it?
all I know about it, because Linda has nagged me about it, is that it is not from our solar system.
It's special, yeah. It's not from our. It's an interstellar object. It's the first known interstellar object. That's all right. Thanks, Linda. Yeah. she's messaging me with info, and I know where she's got the info from because I'm at the same
We'll
place.
thank John saying it's the latest information. It is not cigar shaped; that it is more of a flat disc. And yes, Tony, it does look like a ciabatta roll. Absolutely does.
According to the class there, it says it's a frigid asteroid.
Mm.
It doesn't like to make a move, does it?
No. Well, it came into our solar system, so.
There's, down in the Wikipedia comment, it says, it's funny this. In July 2019, astronomers concluded that Oumuamua is most likely a natural object. As in, it's probably not
I think Miguel's pretty accurate. I think it does look like an interstellar turd.
It's a whale from using a probability drive.
That's right.
Is it a frozen blue whale?
Yeah, that's it.
Might well be a frozen blue whale. So should we finish on this one, or should we finish on Orion? Because I can see that Gerald's got his Orion image sitting in the background here.
Go to Gerald's picture.
Let's finish on Orion. Oh wow, he's not the only one with his image. So here we go. So this is Orion Nebula. Steve, tell us about Orion Nebula, and we'll finish up on this one.
So this is there are two naked eye visible star forming objects that we can see in the sky. And we've actually seen both of them tonight. So the Lagoon Nebula is one of them, and the Orion Nebula is the other one. So the Orion Nebula is the handle of the pan for those of us in the southern hemisphere. In the northern hemisphere, it's the sword, Orion's sword, that hangs from the belt of three stars. It's actually two Messier objects. So the big blob is M42, and it's also a disappearing object. And in fact, that's good there. So the big area is M42, and then you've got the dark area on the top, and then that second blob on the top with a bright star in the middle is M43, another Messier object. So Charles, bless his cotton socks, actually decided that there might be two non-comets in that space.
He decided there was a separation point just here.
Yeah, it's interesting, isn't it? So it's about 1,000 light years away, and in that very bright patch in the middle of the large area there are 4 stars called the trapezium. There's actually 6 stars, 2 of which are quite difficult to see. So normally when you look at it visually, so it doesn't, where it's not sort of flared up, you can see the 4 stars of the trapezium in the centre, and it's those stars that drive the nebulosity. So they're putting out radiation, which is illuminating the gas and dust.
So this is my image from the dark sky site using the phone again. This is 60 red, 60 green, 60 blue, 10-second images. Once again, not as good as the other guy's stuff, but it does show you what you can do with a phone and a telescope.
Yep.
If you're willing, if you've got the patience to stand there and click the button 60 times over and wait. It's a long, drawn-out manual process to do astrophotography, but it's a lot of fun. And that's actually not a bad image for a phone camera. No. It's not as good as Gerald's is, which is wonderfully detailed. Gerald, what's yours contain?
Well, I was just going to say with this one here, I actually took 2 lots of images. I took long exposed ones for the nebulosity, and also took some very short exposures to capture the trapezium, which is those stars you were talking about before, and I've blended those together. So yeah, I think that's what you do, because otherwise this whole nebula becomes very, very bright and blown out.
It's a beautiful image. Now we have Andy's version.
Yeah, this one's overcooked. I put the saturation sliders up to about 11, I think, but just to push the colours a bit. But I did do the Instagram look a minute ago, and here's what I took in 2016. Right? Here's my very first image. I took an astro image, and here's the second one. And this is just the progress, 2018, 2019, and then back to 220. So it's just the progress you get, but seeing that very first image, but I was so proud of that first image, you know, just a couple of blurry stars and a bit of fuzziness around it. But yeah, it is tricky to get. It's probably one of the easiest images to take and also one of the hardest to take because you can just, the very first image you'll get, it's perfect, but then you always get a blown out core. And that's so hard to, and this is a composite too. This is about 3 hours, but I've also done some 15 seconds, but it's still a bit blown out in the core.
Have you ever seen any astrophotography images where they've managed to bring out the trapezium in the middle there, or does it always get flared out?
People can do it. Can be done.
Yeah.
Gerald's here. You can see the trapezium in the middle there.
But that's a composite though.
Yeah.
It's
We've got.
It's not a composite so much as different exposures.
Yeah.
Yeah.
This is Anne-Marie's version.
Which is blown out in the core as well. This is 11 hours and 42 minutes worth.
Wow.
The detail.
Taken with the ED80. And this was taken with luminance red, green and blue as well as H alpha.
So you've got more than just M42 and M43.
I've got the Running Man.
You've got the Running Man as well, yes, over there to the left.
But you see here with the these horrible stars, that was the filters that I was using. I've changed filters since then. I haven't tried Orion since, so I must do that one day. Try and get better stars. Yeah, well, that's right. It will.
What are we doing here, Lee? What are you up to before we tidy it up and close it out?
Yeah, I'm just sort of just mucking around with sort of different methods to add in the core, which I've done as a separate. So you can see, you know, obviously there.
Yeah.
And yet this was the original image. So it's just a case of doing, working on the levels and doing various things to try and add and not add too much and use some masking and things to be able to get the results. But again, same with me. It's been so long since I've done M42 that you know, you sort of the amount of extra little techniques you start to learn on other things. You just sit there saying, you know, waiting for the next 9 months to roll around so you can apply them to other galaxies and nebula.
That's a nice one. Whose is that?
That's mine. It's the same image, but it's been dropped.
The colour, I like that colour better.
Yeah, the left-hand side's much better. So we're now just talking amongst ourselves. So I think we might close it out for the night. Just want to thank the team for coming along tonight. Thank all of our viewers for sticking with us for what's now been just short of 3 hours.
Wow.
Not bad when it's raining outside and we're in lockdown.
Yeah.
That's a pretty good effort. Obviously, you know, we'd love to do some in-person live viewing again. It all depends on what happens with lockdown. If it continues, we'll do another live stream. We love doing them, so keep an eye out for those. If the lockdown gets extended, I dare say that next weekend we will do something live stream because we all get pretty bored sitting at home as well. So we may as well share the experience of astronomy with everybody. If you've got any suggestions, chuck them in the comments section and let us know what you'd like to look at. We might have some other special comments people on next week to help you, Steve. And,
You did well.
we might cover some specific topics. But yeah, thank you very much to everyone for coming along, and thank you to the Herald Sun for sharing our stream to their platform as well. It was wonderful to sort of share what we do with everybody. And if you're not an ASV member, come and join us, www.asv.org.au/join. We're a very, very friendly bunch of people. Got lots of different sections depending upon what you're interested in. And we'd love to have you as part of our team and come and join us at the Dark Sky site. But till next time, we'll see you later.
Bye.
Bye-bye.
Yeah.